to snorkelers and divers who are taking close-up macro photographs of the seafloor, for example. Now, I like to deal really in the middle area of the spectrum, so looking at these aerial vehicles, surface vehicles, and underwater vehicles, and how we can use these to have a nice balance of broad range surveys while still having quite high resolution in that we can see a lot of detail about what species are present. So some examples, at QUT we're doing work with UAVs, so this is a drone video of some turtles that are coming in to nest on a beach, and here we're classifying and tracking those turtles in that video. Here we have some sample footage from one of our autonomous surface vehicles, so this is for mapping a seagrass meadow. And here we have some footage now from an autonomous underwater vehicle. So this is collecting imagery of the seafloor. Just a few snippets to show you these vehicles in action. So on the left, we have a remotely operated vehicle, and on the right, we have one of our autonomous surface vehicles there that's performing a mapping and monitoring task. Okay, so that's sort of the background in terms of the application area. So the ecosystems that I'm looking at, the tasks that I'm interested in. Now from the computer vision and artificial intelligence side, there's actually a whole lot of challenges that we face when we start to deal in this area. So I'm sure many of you will be aware of the types of typical computer vision tasks that we encounter. And so here we have some examples here for the semantic segmentation task, where we're trying to classify every pixel in an image as to one of a set of predefined categories or classes. Now, for these typical computer vision images, so I'm talking in the non-underwater case here, we typically have quite consistent image characteristics. For example, we can normally tell what's in the foreground or the background of the image, and we have sort of a separation between that. The objects that we're looking for generally have boundaries that we can see where the object starts and where it ends. And these factors mean that we can have a high annotator agreement. So for the example in the bottom here, we can see that we have a person riding a motorbike. That's what's the foreground of the image. And if we label that image, probably most of us would draw a similar boundary around the motorbike and around the person, and we would all agree on what we've seen in that image. And what this means is that you can go ahead and use crowdsourcing, like Amazon's Mechanical Turk, to label really large quantities of images quite cheaply, and it's very accessible to do so. And there's a lot of imagery and data sets of this type already on the internet that you can use as well. Now, in underwater imagery, really none of these rules apply. So we have huge variation in the image characteristics due to factors like depth, the lighting of the imagery, the camera angle that the photos are being taken at, and then things like turbidity and blur as well. So these can significantly degrade the quality of the images as well. Underwater images are usually highly complex, so you can have many overlapping instances within the image, and we have very poorly defined boundaries as well. So it can be very hard to tell where one coral ends and where the next coral begins. There's a lot of overlap, and it's very difficult to tell where that boundary really lies. There's also a lack of objectness. So oftentimes we don't really have objects in the images that we're looking at. Here we can see the seagrass is really a carpet growing over the seafloor. So it's kind of hard to know what the foreground or the background is, or where the thing is that we're trying to look for in this image. And then we have environmental factors too. So the species that we're looking for, they'll often change during the year, so the visual characteristics will vary quite significantly. And then you could have the species change its appearance based on the location it's growing in and based on the conditions that it's growing in as well. So whether that's on the exposed side versus the protected side of the reef ecosystem that it's growing in. And then we can have visual similarities between different species as well. So to the untrained eye, we can see, some examples here of species that are different. In fact, for the corals, there are entire families of corals that are different, but that look quite similar if you don't know exactly what you're looking at. So So all of this to say that underwater imagery must be labelled by marine scientists or by domain experts. That means it's very time consuming, very costly. Oftentimes it's hard to find an ecologist who has the expertise needed to label the imagery, and then even harder to find an ecologist who has the expertise and is willing to spend days or weeks of their life labelling the imagery for training a deep learning model. So this is really the root cause of my topic today, which is reducing label dependency for this application area specifically. So we want to move away from needing large quantities of labeled data because it's so difficult and expensive to obtain. So this leads me now into talking about some bodies of work. So the first one, of course, is seagrass. And here we're talking about the task of multi-species coarse segmentation, which I'll explain to you now. So there is a typical photo of some seagrass. We have multiple species growing together. Hopefully you can see that it's a very cluttered, complex image. If we asked an expert to label this image for a segmentation task specifically, so if we're wanting to draw these boundaries around every single leaf in the image, this could take hours. I think the annotation that you see there took, 5 hours or something like this, just for that section alone. So instead we deal with this task of coarse seagrass segmentation. So here we're performing inference as a grid over our image, and we think that this is a nice balance between having enough resolution that we can see what species are present and how much of each species is present in this image, while still cutting down on that annotation cost. So this is the task that I'm going to present to you now. We started this work back in 2020 and proposed this data set called Deep Seagrass. And this work proposed a semi-automated dataset collection methodology where we would collect whole images containing just one species at a time, and then decompose those images into patches and create quite a large dataset quite deeply and quickly in this way. That was the prior work in 2020. We then had follow-up work where we wanted to reduce the labeling even further. So in this work, we've moved away from having those patch level labels to just requiring the image level label only during training. And this significantly reduced the labels required while still having that same patch level coarse seagrass segmentation output at inference time. So how did we do this? Let me give you an idea. So we proposed an ensemble of two complementary classifiers. So two classifiers working together in slightly different ways to produce our output. The first method is called CFeeds, and this is based on contrastive training. So we used the unsupervised contrastive loss sim CLR to initialize a feature extractor. And then we performed end-to-end training using our feature similarity loss. So what we did here was we took query patches in our training images, and basically we created a template for each of the classes present simply by averaging the feature vectors from that pre-initialized feature extractor that I mentioned earlier. Then what we could do is basically use a cosine similarity to compare our current query features to that set of templates that I just mentioned. And we can say, if they're closer for one class than the other class, then we can pseudo-label based on that cosine similarity. And that basically gives us a pseudo-label that we can then use for training end-to-end. And the nice thing about this is that we can update these templates during training as well. So as the model learns more about each species, we can update those template feature vectors there too. Now, the second classifier in this approach is called CClip. And this was basically leveraging the CLIP vision language model. So that came out a few years ago, trained on a really large amount of internet data. And it's nice because it actually produces a shared embedding space for natural language and image features together in that feature space. And so we can use CLIP then to create pseudo labels for patches within each image. So we query CLIP using natural language prompts, and then take those CLIP probabilities as the pseudo label. And here what's nice is that CLIP itself doesn't have a good understanding on different species of seagrass, but it does have the ability to tell the difference between sand, water, and seagrass broadly. So when we combine the coarse label, i.e. seagrass, with the image level label provided by the ecologist, this means that we can combine CLIP's general knowledge of the world with a very domain-specific knowledge provided by an ecologist. And we combine these two methods together to give us even more robust performance as an ensemble of classifiers. And here we can see our model performing inference on that autonomous surface vehicle that I mentioned to you earlier. Now, this has great impacts in terms of being able to map coastal ecosystems that previously haven't been mapped, which then has flow-on benefits, of course, for livelihoods that rely on those ecosystems. Okay, so now into that next body of work, and this is now looking at coral reefs and a segmentation problem. So for this problem, what we're dealing with is a whole lot of historical prior data that has been labelled by ecologists using these randomly placed point labels. And this is very, very common in this field, that ecologists will label the images in this way and then extrapolate those points to provide sort of percentage estimates of what species are present. So if you had 2 out of 10 points, they would say it's 20% of that species. So that's why we have this large quantity of historic data. Now, as I'm sure a lot of people are aware, when we have typical semantic segmentation, we need more than just those sparse points. We need a dense ground truth mask where every pixel in our image is labelled, and then we can use that alongside our training image to train our semantic segmentation architecture end to end. If we just have the sparse point labels, we need to do something a little bit clever. So here we focus really on this point label propagation task that it then spreads out those sparse point labels in the image, and we can then use that to train our segmentation architecture as usual. So we propose for this a new superpixel approach to do that point label propagation task. And here we consider these point labels directly in that loss function. So we ensure that each superpixel contains just one type of coral at a time. And we enforce this by using 2 terms that work together to group similar pixels while ensuring that if there are points with different labels, they get pushed into separate segments. And hopefully you can see here the superpixels at work. So they kind of spread out where there's just one class present, and then they really group together and become way more intricate in those more cluttered or complex regions of the frame. We then built on that work just last year by considering the extremely sparse label setting. So in the work I just presented, we were really assuming that we had between 100 and 300 point labels per image, and that was kind of the typical use case for that work. But then we thought, well, what if you're labeling new data and you only want to label 5 points per image, for example? So in this next work, we tried to really cut down on the number of points required. So here we leverage the Dino V2 large foundation model. So this came out recently. It's a really powerful feature extractor trained on a whole lot of images. And so we thought, does this have some useful general knowledge that we can leverage for a very specific task? So we sort of lean on the idea I presented earlier of creating templates. So once again, we create templates for these sparse points that we do have labels for. And then we can do some simple clustering in that feature embedding space to create our augmented ground truth mask. So this is a very, very simple approach, but we find it works really well because of the power of that Dino V2 feature extractor. Although Dino V2 doesn't work well at all when you use it straight out of the box on a coral image, because it hasn't been trained on coral images, it does still have very useful features that we can leverage with just a little bit of extra work. In this work, we also proposed a human-in-the-loop framework to better make use of those few point labels that we have from our ecologist. And so what we do is we take our Dino V2 and KNN, as I just described, and we actually use the cosine similarity to create a map to the nearest known labeled pixel. So this shows us where in the image we maybe don't have a template for the type of coral that's present. So maybe we have part of the region that wasn't captured in the point labels, or maybe it looks a bit different for some reason, and that should tell us that we need another point in that location specifically. We also combine that with a distance map, and this is to enforce exploration in this approach. So we don't want our expert to continue to label in the same part of the image. We want them to explore somewhere new. And if we combine these two things together, we can then find and propose the desired next location for our expert to label. And we can do this in an iterative way until we reach some desired number of point labels. And at that point, we can then create those augmented ground truth masks and use it to train our model to perform semantic segmentation. And we can see that this significantly improves our results, particularly for cases where you have a small number of point labels. So what we can see here on this side is that if you have just 5 labels or 10 labels, then where those points are placed is very important and significantly impacts the performance of the approach. If you look more in the 200 to 300 pixel range, then at that point you have really sufficient pixels, so perhaps using the human in the loop approach is not as critical in that setting. And here we have just some examples that show how our augmented ground truth masks perform, even in this case when we only have 5 point labels. So in terms of impact, I think it's important to flag here that there are more than 800 species just of hard corals alone. So I think it's important that we move away from any idea of having one global model that will work for every species. Instead, we need to do this fast, annotation-efficient model retraining or fine-tuning. And this approach that we've presented significantly moves us towards this goal. We really reduced the labels required and showed that there still is value in having some degree of human expert knowledge in that annotation part of the pipeline. And now just finally, I'd like to touch on my current and ongoing research. So this is really moving away from the monitoring task as I presented in the first 2 bodies of work, and now moving more towards intervention. So we want to really do something to save these ecosystems. So here we're looking at really active reef restoration using robotics and AI. So here we have basically coral devices. So what we're doing here is we're collecting coral babies, putting them in that tank facility that I mentioned earlier until they can grow to a mature phase, and then they get put in these little coral devices you can see here, so that when they're put out on the reef, they're protected from fish, and so that they don't float away in the ocean. Now, there's sort of 2 parts of this process. Firstly, growing those corals, and then we need to put them back into the ocean. So on the first stage, what we can see here is a robotic arm that's equipped with a high-resolution camera, and it's running computer vision algorithms in the background, as you can see there on the right. So here we're doing object detection for the different types of coral babies that we're growing in this tank, and this enables us to optimize their growth conditions, things like how many nutrients they have available, how much the water is flowing, these sorts of factors. Then once we have these corals, what we're then able to do is deploy them back out into the ocean. So this work is leveraging some of that prior work that I showed you for the seagrass. So here we're once again doing this patch level classification task. And then what we're doing is aggregating those patches over the frame to decide whether or not this image or this area is suitable for those corals to be redeployed back onto the reef. So we're checking for things like, is there too much live coral already there? Is there too much algae that's growing that's going to affect those corals? If it's too sandy, the corals might roll away. So there's a lot of factors that we're interested in. Here we can see our algorithm at work. So we have a boat with a camera system on the back, and in real time our algorithm is determining whether that substrate is suitable or not for reseeding the reef with those coral devices. And we can track these locations and create a GPS map of the deployment, as you can see there. Okay, so just to wrap up before the end of my talk now, just a few ideas about future work from here. So the first thing that I encounter quite frequently is the issue of turbid water. So the approaches that I presented today, they really can only be used in good conditions. As soon as there's a lot of sediment suspended in that water column, that turbidity affects the imaging and prevents us from being able to effectively see what's in that image and make a good decision. So I think it would be really interesting to both investigate deep learning approaches to mitigate this turbidity, and also look into other types of sensing modes as well, and potentially even non-visual imaging systems there too. I'm also interested in the idea of fine-grained recognition of ecological indicators. So this could be the amount of bleaching that's occurred, how dense or sparse something is growing, or how healthy a species is as well. So oftentimes we're performing classification of categories that are clearly defined, but in ecology, more often than not, these things that we're trying to detect are actually continuous in nature. So I think that there's more we can do in this side of the problem as well. And then I also have more ideas about how we can leverage these large language models and large foundation models. So I talked a little bit about using CLIP, which is a vision language model, and that was quite effective for giving us some general knowledge of the world and then combining that with specific domain knowledge. But I think that there's really a lot more that we can do down that track, and specifically for the problem of open set recognition. So if we don't already have examples of a species, maybe we can leverage some sort of natural language prompt that still enables that species to be detected in an open set or open world task. So that's all I wanted to talk about today. Thank you so much for listening and attending my talk. I'd love it if you wanted to connect with me. There's a QR code there on the screen. And I'm not sure how we're doing for time, but if anyone had a question, of course, I would be more than willing to answer that as well. Thank you.
Okay, so I believe there are no questions, and I'd like to thank you, ma'am, for such an enlightening session. Now, I'd like to invite Dr. Anil Kumar Shukla to present a certificate of appreciation to Dr. Scarlett.
Thank you so much.
Thank you so much, madam, for your very interesting lecture on current topic. So many researchers, faculty, students have joined through the Amazon.net. It is a virtual platform, and they have enjoyed it out. Thank you so much once again. Hope
Thank you so much.
In the next spin also.
Absolutely, I really appreciate it.
Thank you, ma'am, for being a part of SPIN 2025. We are grateful to have Dr. Priyank Khare with us today, joining alongside our esteemed session chair. I would like to invite Dr. Anil Kumar Shukla to present a sapling to Dr. Priyank.
Thank you so much, Dr. Priyank, for joining SPIN 2025.
Good morning,
Thank
sir.
you so much.
Good morning, sir. Thanks for providing the opportunity to me to chair this particular session. Thanks a lot from the organizing committee.
Right. Dr. Priyank Khare received his BTech in Electronics and Communication Engineering from Uttar Pradesh Technical University in 2009. MTech in Digital Systems and PhD in Electronics and Communication Engineering from the Motilal Nehru University of Technology, Allahabad. Prayas, India in 2014 and 2021 respectively. He is currently employed as an assistant professor in the Electronics and Communication Engineering Department at the Indian Institute of Information Technology, Ranchi, India. His interests include digital image processing, digital image water marketing, multimedia security, medical image processing, and data hiding techniques. He has authored several research papers in reputed international journals and international conferences. Welcome once again, sir.
Thanks a lot.
Sir, would you like to continue with the paper presenters, or should we wait for Dr. Seema?
As per the norms, no issue. As per the protocol, if you like, you can invite participant for the paper presentation. As
Okay,
per
sir.
your decision.
Okay, sir. We can wait for 2 minutes
Okay,
for Dr.
fine. Okay.
Thank you, sir. Unfortunately, Dr. Seema won't be joining us today, so Mr. Priyank will be continuing with the session. Should I call upon the paper IDs?
Yes, sure. Proceed.
Okay, thank you. So now I'd like to call upon paper presenter ID number 235 to present their IDs. And Mr. Summer, before doing that, please show us your presenter ID.
Hello, ma'am. How can I show that presenter ID, ma'am?
If you can turn on your video, or if you have it like in a hard copy, or if it's online, then just present your screen, please.
Just a second, ma'am.
Yes, you're visible. Ravi, same here. Excuse me, sir. If you are able to find your ID, then you can start with the presentation and show the ID at the last. Thank you.
Ma'am, can I start?
Yes, please.
Very good morning to all the board members and presenters here. Uh, my name is Samar, and today I am going to present my work on improvisation of ESR GAN for upscaling surveillance video. So basically, my work is on improving the resolution of CCTV footages, which is definitely on low quality. So to improve that, the basic uh, thing I have followed is that first of all, the main challenges first I want to discuss is there are various several lighting issues and identification issues in the low quality images. So to improve that, I have worked on this model. The methodology I have followed, the basic methodology I want to discuss is uh, first of all, my model extracts the frame from the lower resolution video, and after that those frames can be treated as images, and those images are improved further. And after that, by combining all those images, or we can say all those frames, we can make one video. By this way, I have implemented my project, and I have majorly taken reference for my project from real ESR GAN, and by improving real ESR GAN, I have worked on my project of improved ESR GAN by hyperparameter tuning, like batch. I have changes some hyperparameters like batch processing and learning rate, and various other factors that I have changed. After changing all those factors, I have trained that model on my dataset, and after that, I have got my improved ESR GAN model, which is now capable of upscaling those videos, which is now currently available in lower resolution. So after that, there are some results and discussion I want to show you. Like if I talk about original ESR GAN and improved ESR GAN, there are some differences between in the uh, image quality, which I can show you further in the form of PSNR and SSIM values, which would be more accurate in terms of values. And after that, uh, there are some evaluation matrices there I want to show. Like if you can see here, PSNR ESR GAN is in lower in value as compared to PSNR improved ESR GAN, which shows that the PSNR improved ESR GAN is much better than PSNR ESR GAN. And PSNR ESR GAN is just the distortion value, which shows how much image is distorting. And SSIM is like perceptual quality, which shows the perceptual index of the image, is like that how much features are exactly the related or in similarity with the original one. SSIM value is that only. Okay, so SSIM value for improved ESR GAN and SSIM ESR GAN uh, is much higher than SSIM ESR GAN. So by this way, I can say that the model I have worked upon is perfectly working on, particularly on surveillance video upscaling. And conclusion of this project is like that due to the lower availability of SAYS, because if we talk about CCTV footages, they works all the time, 24 hours a day and 7 days in a week. So to store that huge data, we are required to compromise the quality, and by this way we got the disadvantage of getting the less identification of the activities and the persons including in that footage. So my model particularly tackles that problem, which would help us to increase the quality and save the space of the footage in coordination with those of the problems. I've taken some references from many research paper to implement this model, and this is all about the model of mine. Thank you for listening me, and this is all about it. If you have any questions, then let me know.
Okay, I believe there are no questions. Sir, could you please show us your ID if you have?
Excuse me, I have certain question from Samar. Samar, can you listen me? Can you hear me?
Yeah, yes, sir.
Okay. So first of all, I have a one query that how have you acquired the images for this particular task? What is the process you have applied for the image acquisition? May I know?
For training data sets, sir, I
No,
don't
I
get
am
the.
just asking how do you have acquired the basic images? First of all, you have said no data collection you have done. Okay.
Yes, sir.
So how do you have acquired those images? May I know that?
Sir, I have extracted those images. I've created my own data set. Let me tell
From
you how
where
I
you
have
have
done
extracted?
that.
From where you have extracted?
Sir, I have taken out the video. First of all, that video was around 23 minutes. So what I have done is I have
Hmm.
taken that video and extracted some 10 seconds frame, because for 23 minutes it would be very much images. So for 10 seconds I have got around 60 images and 600 images, I guess. 600 images. And after getting those images, I have downscaled those images for lower resolution so that I can acquire the lower resolution video. By combining all those lower resolution images, I would get the lower quality CCTV footage. And on the other hand, I have the video of 10 seconds which is in higher quality. So by this way, I have the two datasets of higher quality and lower quality, and both of the videos includes frames which I can extract further to get the images and frames. That's how I
Okay.
have done that.
The second query which I have done, how your ESR gang is different from the normal conventional advisor network? What is the difference? Main difference you can think of ESR gang.
uh,
How GN is how different from GN, normal conventional GN. And what does ESR stands for? You have not specified in any of the presentation slides. What does ESR stands for?
uh, Enhanced super resolution. This is enhanced
You have
super
not mentioned.
resolution.
You should be mentioning, and you should also
Yes, sir.
mention what is the main impact of ESR gang over the normal conventional gang. Okay.
So,
Yes. Can you answer this?
yes, sir. ESR GAN and GAN are two different things. GANs are the basic adversarial network, and these networks are generally to create the images on simple interpretation. But the ESR GAN, we train ESR GAN on different images like
No, no, I'm just asking
VSR
what
net.
is the thin line of difference between these two processes? Only the thin line of difference. What is the operation wise difference between these two gens network? Just only I'm
Yes, sir.
asking. So please see to it. If you don't, please see to it. And third thing that
Hmm.
I was missing that in the entire presentation that you have not cited any references. Okay, when you are doing or presenting
Hmm.
some work, you should be
Hmm.
able to what the work you have taken from where you have taken the sources. You should acknowledge them. Okay, so you have not in your entire presentation that was missing, lacking one point that you have not fully cited the work. So please ensure that once you present
Okay.
next time or somewhere else, please acknowledge the work done by the other researchers. Okay,
That is my
thanks a
first
lot.
time, sir. I would consider that.
Thanks a lot. Very good work. Okay, thank you.
Thank you, sir. Before moving further, I'd like to request Mr. Summer to show his ID once, please.
Where I would get that, I am actually not getting it. On the mail, or where I can get that? Like, I have received this mail. I can show you.
Any of the ID proof you have, like with you, like any Aadhaar card or anything.
Yeah, I have that. Just a second. On the camera, ma'am, or I need to show the document?
You can do it on the camera. You can do it on the camera. All right. Thank you so much. Now I'd like to call upon the presenter ID 244. And before presenting, please show us your presenter ID.
Hello, I'm Nitish Kumar Saha, the presenter of 244.
All
Shall
right.
I share my screen?
Hi, we can see your camera opening and your presenter ID, please.
Presenter ID as my ID card, right?
Any of the verification proof like your Aadhaar card or your driving license, any.
I'll just share my screen and show my ID card. Is my screen visible?
Yes, it's now visible.
Yeah. So this is my ID card.
All right, thank you. You may start
Is that
presenting now.
okay? Okay. So
हमें उठा के लेके जाना पड़ता बैलेंस
So good morning. Good morning, everyone. This is me, Nitesh Kumar Shah, from Triple ID Allahabad. Today, I'm here to present my paper named Novel Adaptation of Unit Framework for Cross-Domain Climate Data Translation Using Enhanced Feature Preservation.
Nitish,
So,
can you make
the
full screen? Make it full screen, Nitish.
Okay, just a minute. Actually, I'm not there. F5, I guess. Just a minute, I'm not getting it. Yeah. So I'm Nitesh Kumar Shah from Triple ID Allahabad, and my paper is Novel Adaptation of Unit Framework for the Cross-Domain Climate Data Translation using the Enhanced Feature Preservation. With the Enhanced Feature Preservation, so the presentation flows goes from the introduction, literature survey, dataset, methodology that we have used, experimental setup, and the metrics, the evaluation metrics, the evaluation, conclusion, and the references. So, coming to the introduction, I just want to say that the motivation behind this paper was to enhance the climate data set, which was climate data set of the adverse weather conditions, which was which some kind of model uh, struggles to predict, and also like it can't be enhanced or it can be captured with that kind of precisions. So the challenge were like the poor geospatial specificity, ineffective feature preservation in climate data sets, inability to handle the multivariable dependencies, like seeing all the scopes, all the feature of the of a object that is present in the image itself. And the proposed solution that we got after it was by using some kind of by using different kind of landmasks, by enhancing the deconvoluted neural networks, and selectively using some loss functions that we'll see in the next slide. And the impact was the improved feature preservation and for the reliable climate modeling. So the literature survey, the first thing the first thing that we have enhanced the unit unpaired image to image translation GAN, which uses variation or auto encoders and some other models, which is motivated from deep convolutional neural networks of DC GAN. And the challenges that we got in the challenges in the climate data was was there to be enhanced. Uh, Coming to the data sets, we worked on two different data sets. The one was the BDD 100K data set. It is the largest autonomous driving data set with almost like 1 lakh images and videos, which covers the diverse driving conditions from cities like New York and San Francisco. The second data set is the FS 2020 data set, which is there in Kaggle also. So this particular data set is almost like 6,000 images, and it provides it gives a holistic idea about the semantic segmentations and the line level of different different for different domain agnostic task, I would say. And both the data set are validated for the proposed model efficacy with the different domain without the requirement of the additional data sets. Coming to the methodology that we proposed was using the variation autoencoder generative adversarial networking framework, where we are using two different kind of generators and two different kind of discriminators. You can see here in the flowchart itself, like we are taking a input image, be it a climate data or a image which doesn't have any adverse weather conditions. Then after we get that particular image, we are doing the downsampling of that image, and then we are keeping that image. We are doing downsampling, and then we are keeping that image into the residual block, which is being saved by the generator X and Y through the latent space. And then after that latent space, we are going we are ensuring that our data is being uh, uh, our sorry whatever representation that we got after the said part is being is being reconsidered by the reformation laws, which is the novelty part of our of this particular paper. And then what we are doing is like after we are getting the output image from those two different latent space, we are keeping that into the discriminator and discriminating whether whether the generator is able to generate the image which is as good as the real image or not. So the discriminator has a real image uh, of the following image of the following domain translated image. So whether using some kind of conditional probability, using that, it is predicting whether the image is being translated perfectly or not. So this is our methodology for the experimental setup. We used like alternative training. As we said that we are using variational autoencoders model in GANs. So we would say like although we are training we are training with generator and discriminator, uh, still we are using the concept of encoders and decoders in the generator and discriminator. For the hyperparameters, we used Adam, where the learning rate was 0.0002, and the training until convergence on the test data sets. The evaluation metric that we took was FID, which is French jet intercept distance, which is to judge the feature vector, which is to judge the feature vector of the real and the translated image, like judging the feature vector of the real and translated image, whether it is perfect for the localization purpose or not. And learning perpetual image patch similarity, LPIPS, is some kind is one of the famous and one of the kind of deep learning network which is used judge the efficacy of the model, whether the converted image looks as real as the real image or not. So, and the structure SSIM is like to just the semantic segmentation and the spatial feature retentions. So the outcome was we got the enhanced feature preservation and the superior image translation accuracy of the baseline that we took. And the baseline scores and the result metrics are as follows. For the dataset of BDD 100K, we compared our model with two different GAN. One is today GAN and the other is PatchGAN. Actually, PatchGAN is famous for the data. PatchGAN is famous to generate, like to translate a rainy image to de-rain a image or translate into a rainy image. And today GAN is famous for the task of day to night and night to day after the cycle GAN. So we took these two different kind of GANs and we compared our scores. Here, the lowest score in the FID means that the model is better. So we got the scores which was the lowest in all the three cases, that is FID, SSIM, and LPIPS. After that, this is our result that we got. Like A, B, C is the domain image that we took, the input image, and D, E, F is the output image of the following. So A to D is day to night. B to E is also like B to E. Okay. B to E is from night to better night, and then C to F was we were trying this on the climate data set to convert a sunny image to a snowy image using some kind of using the same technique, but we used stochastic differential equations there. And then coming to the part of the contribution, we developed a RoboScan framework using the VAs, and the advantage is that it outperforms the existing models in spatial accuracy and feature retentions, and it integrates the shared representations, modulated convolution networks layers, and the custom loss functions, like the loss functions that we took explicitly after after whatever there it is present. Was the first one was the reformation loss, and the second one was the reconstruction loss, which is as similar as the reformation, but it was somewhat a bit different. And the limitations and coming to the limitations and the future work, it is sure that if we are using if we are using the deep DL models, we need a there is a high competition loss, high computation cost. We used A100 GPUs for this, and the future work is to optimize our architecture and to use different kinds of VIT networks like the vision transformers and some restormers to enhance our result in a better way, to improve the FID scores and the LPIPA scores better. So this was the reference, and we want to thank. And it was funded by News and IDEC IEEE Allahabad. Yeah.
Hello.
Hello.
Okay, Nitish. Okay.
Yeah.
Okay, I
Yes,
have
sir.
two queries for you regarding this presented work. What features you have selected when you're talking about the climate data set? Any features you have selected?
Okay. Like the first feature was to convert the day image to the night image, and the second feature was to convert the day image to a snowy image.
Okay, no physical parameters you have considered such as humidity, temperature, pressure.
Actually we tried doing that for fog,
Okay,
but the thing is that uh, we didn't really get a better result in fog. Actually, we tried it for fog, but yeah, we didn't get any better result for the fog one.
you can. I think this work can be extended for some other features also, such as humidity, pressure. You will get the better result. I think.
Yeah,
Okay.
yeah,
Okay.
yeah.
And second thing, the last query which I am having. You in the block diagram, you have defined two generator circuits, X and Y, and you have two discriminator circuits. And the last discriminator is predicting the value between 0 and 1. Is it fine? So how can discriminator can be trained, or that values can only lie between the interval of 0 and 1?
Actually, the thing is, we are providing a real image to the discriminator.
Okay.
It's there already. So the discriminator is like, we are not training the discriminator. We are just providing the real image to the discriminator, and it will give the probability score between 0 to 1. If the probability score, the result that we are getting, if the
So
discriminator
is going to compare the provided input image with the real image. Yes or no?
not the provided input image with the real image, but
then how it is going to differentiate between these two images? How should it be?
Actually,
yes.
The thing is, for example, if we are giving, if we are training the model, right, we will give input A and input B. So the one is the day image, and the second one is the night image. The day image will be converted to the fake night image, and the real night image will be compared with the fake night image using the discriminator. That is what we are doing here.
Okay. Then you are predicting the exact probability for that value.
Yeah. That's why we have that probability score.
Okay, fine. That's only. Okay, thank you. Very good work. Okay, thanks. This is from my side.
Yeah, okay.
All right, thank you so much. Now I'd like to call upon the presenter ID 247 to present, and before that, please show us your presenter ID.
So, do you hear me?
Yes.
Let's see my presentation. This is my ID.
It's a bit blurred.
Yeah. Just a minute. Huh?
All right, thank you.
So, greetings, esteemed colleagues. My name is Alexey Torpov, and I'm here to present our research focused on specialized image descriptors adaptation for deep Black-Ocky recognition in microscopic images. Automating visual data analysis is crucial in microbiology, where microscopy images present challenges like complex patterns and low contrast. And traditional classification methods struggle with these issues. Our research focuses on lightweight, interpretable descriptors for classifying deep Black-Ocky microorganisms. And this approach improves accuracy while reducing computational costs, making biomedical image analysis more efficient and accessible. In biomedical image processing, especially for computer tomography scans, prior research has highlighted the benefits of tailoring neural networks methods for specific tasks, enhancing efficiency, speed, and output quality. Similarly, advancements in image processing with embedded text fragments have demonstrated the potential of models optimized for central processing units, balancing resource conservation with effective multimodal text and images analysis. So our work investigates these approaches by introducing specialized descriptors, combining resource efficiency and with precise hierarchical data interpretation. And this approach enhances performance in tailored application, particularly in challenging multimodal tasks. We introduced a novel approach to specialized image descriptors, originally developed for analyzing images with embedded textual content. These descriptors are designed to extract the most meaningful information from the spatial relationship of areas exhibiting significant brightness fluctuations. And these descriptors are formed as paths traced by agents navigating the image from predefined static points following the specific movement rules. Image descriptors type 1 follows a specific movement strategy for agents. At each step, the agent determines its movement based on a predefined rule. Image regions are defined for each movement direction, and the L1 norms of the differences between the top-bottom and the left-right regions are calculated, and ultimately the movement direction is chosen based on the higher norm differences. Considering an additional bonus for moving in the priority direction. These trajectories align closely like the contours of the input image, as shown as in the figure 1. All the trajectories are grouped by priority directions and initial positions the way it's shown on this slide. And finally, we merge groups of trajectories for each direction into the complete image descriptor. Image descriptor type B differs from type A only with the movement direction rule that is presented on the slide. So alpha equals 1 if the movement direction has changed at least once and 0 otherwise. And this modification allows the agent to avoid priority direction influence if the significant element was found during the agent's movement. Image descriptor type C is also based on the agent's trace concept. However, each movement type is selected according to the variance, and the description image descriptor type D is an approach we introduce in the context of combined schema. We use the combined two-fold feature extractor engine as an image descriptor. We use two efficient net variants simultaneously to get image embeddings and concatenate and project these embeddings to fit the classifier input. Therefore, this approach is not agent-based and uses well-known building blocks, simplifying the overall architecture. And the final scheme of our background feature extractor is presented in figure 3. We use EfficientNet B2 and EfficientNet B3. This combination showed the best performance in the feature extraction task. Image descriptor type E is based on trainable image descriptor extraction procedure, similar to image descriptor type D. However, instead of training a convolutional neural network, we use the gradient descent optimization for movement strategies, parameter tuning. We use the same agents trace-based descriptor building approach as for image descriptors A, B, and C with a modified trainable step direction selection rule posted on the slide. So convolutions with presented kernels stand for the usefulness of movement along the corresponding direction. So to develop and assess the performance of our classifier as well as to benchmark it against our models, we created and published a specialized dataset. The dataset contains approximately 5,000 images organized into two primary categories. The original images were captured using Levenchuk MET D 30T microscope, and you can see some samples on this slide. We're using the precision, recall, and F1 score metrics to validate our results for classification task. And you can see results in the table 1. Our experiments reveal that while some descriptors perform similarly well in identifying microorganisms in microscopic images, not all achieved the expected accuracy. This limitation likely stems for their reduced ability to highlight subtle morphological contours, which are crucial in this application, but differ from their effectiveness in processing images with textual features. Moreover, extensive hyperparameter tuning did not yield significant improvements, suggesting that certain
Excuse me, I'm
descriptors.
sorry to interrupt. Due to time constraints, I'd like to kindly wind up in 2 minutes.
I'm just a few seconds finish. So in this study, we developed a robust approach for classifying the Plakoki microorganism, and our proposed solution demonstrate competitive performance across standard evaluation metrics. And the future work could explore extending these methods to classify our microorganism captured in similar conditions. And thank you for your attention, and I look forward to answer your question.
Okay, good morning. Okay, so I have one query. What the accuracy you have achieved from your process, from this work? What is the maximum accuracy you have achieved? May I know?
We achieved
It is not
around
mentioned in the work. It is not mentioned in the work. Just why I'm asking. What is the maximum accuracy you have achieved? You've attained?
our specialized descriptor type E achieved an accuracy at about 98%, and it's competitive with more
So
complex
that was
neural
training
networks.
accuracy, or well, which accuracy? Training accuracy you are getting 98%, or validation accuracy? Which accuracy you are getting 98%?
We have a dataset split by training, test, and hyperparameter tuning. So it's
Okay.
accuracy on the test dataset.
Okay, okay. And second thing, that while you are defining the image descriptor for type A images, you have considered 4 directions. Yes or no? North,
Yes.
south, east, east, west. So you can consider more 4 cardinal direction, north, east, west, south. It will be a better, much hyperparameter tuning, more resolution. You have only considered 4 direction. You can consider more 4 direction also for result enhancement, I think.
Yeah, of course. Thank you for your advice.
Okay, try to incorporate this suggestion. It will have you something good results. Okay.
Thank you. Thank you.
Thank you. Very nice work.
Thank you so much.
All right, thank you. Now I'd like to call the presenter ID 258, and before presenting, please show us your ID.
It's okay?
Yes, thank you.
Thank you. Very good morning. I am Muhammad Zahir Tanja from Mangalore University. I want to present my work, pre-trained encoder-decoder for breast ultrasound segmentation. Outline, introduction, methodology, experiment setup, future work, and conclusion. Like still breast cancer leading cause this in the woman and worldwide. If early detection, 99% survival rate will catch an early stage, but like only 27 survival rate after cancer spread. Regular screening in virtual for early treatment. Why ultrasound? Like no harmful radiation, more affordable than other screening tool, show real-time image, good for detecting abnormality in dense breast tissue, helps guide doctor during biopsies. But this ultrasound image have some issue like poor construct between different tissue, shadow that hide important area, unclear boundary between normal and abnormal tissue. Also, if there is vocal noise, make image grainy. Also, there are some doctor challenges like time consuming to analyze many image. Different doctors may be interpreted image differently. Complex breast structure make finding problem difficult. Our methodology, we start with because this ultrasound image have some issue. We start with image enhancement. We do Clahi construct limit additive histogram equalization to improve image construct to make stable details more visible. Also use Gabor filtering for capture important texture pattern to help identify different tissue type, and Gaussian blur for reduce noise image and smooth out of unnecessary details. For like our AI models, because we do segmentation, we need like output also image. For that, need encoder and decoder. For encoder, we do like we use mobile net pre-trained module. This module have like we can say like module have already some experience about image and take important image of future from image. Also, we add like a dense layer. This layer for focus on the important important future, and like filter take important future and like remove unimportant information. For decoder, we do like decoder to building our mask or segmenting of Tamur. We use like special layer upsampling, COM2D transpons to receive fine details and maintain special accuracy. Like this general architecture, like for work. Our data set, like we use the BUSI data set, this is like a public data set. It is collected by Dubiani et al. Like it contains 780 image taken by two devices, LOQ, LOGIQ E9 and LOGIQ E9LG. It is like three category. We have 437 image milligauss, 210 image begin, and normal one. 437 image begin and 210 milligauss and 133 normal. Our result, like this one. Table like compare our result with another with recent method like segmenting for same data set BUSI. Like in our result, we got like good accuracy for IOU. This is more important like in segmentation. Also good accuracy. Like this visualization for our result. This is ground truth and module prediction. For future work, we want to like change some, improve our work, maybe use, because we use entropy loss, we will try to use like dice loss for local loss function also try to work on transformer now. With conclusion, like we successfully combined between reprocessing with mobile net architecture. We like addressing challenging low constructs, vocal noise, acoustic shouting. We got like a good IOU scoring. It is good for showing like potentially for clinical application. Like this, our reference and red bar. Thank you.
Okay. Good morning. Am I audible to you? Am I audible?
Yes.
Okay, sir, you have used mobile net architecture for the image segmentation, is it?
Yes.
Okay, what other architecture can be used for the segmentation of the images? You have tested only with one model.
One model.
Yes, you should be testing with at least 2 or 3 models to have a comparative analysis. So you can name other models that you can have segmentation for the images, mammogram images.
No, ultrasound image.
Okay, ultrasound images. So you can have comparison of 2 at least models. So what models can you have for comparison? Name other models you can recall. You have only used mobile net. Yes or no?
Yeah, we try like we compare with UNet and Signet. We can check for like.
I think this is a pre-trained model. It is a pre-trained model, mobile net architecture.
Yes.
It is a pre-trained model. Okay. And second thing, what I found in your work is that you have a less accuracy as compared to reference number 19. You have a less accuracy.
Okay.
So why is it so? Have you observed that phenomena? Why it is coming for your proposed work?
You mean number 19, like Leo et al?
Yes. You have shown that you in your result tabulation you have shown that you have got 97.13. I am remembering the exact data, and your accuracy is around about 95, I think. Okay.
Yes.
So why? Okay. So why is it so that your accuracy is lagging behind that paper, that work?
You mean like why some like precision more than me or another?
No, it should not always be more than you. It should not be always be more than you. It's because the tuning parameters are different. Okay.
Yes.
Or the model tuning parameter will be different. Just I am saying, please look into the matter that why your accuracy is less, and you should have a proper reason why it is. When you are comparing with some work, you should have a valid reason why it is less in comparison to the fundamental work. Okay. Just look into the matter.
Yes.
It should not be always high because the parameter will be differing. And the third thing, my suggestion to you is that please consider the noise analysis for the ultrasound images. It is very, very important thing. Okay.
Yeah. Okay. But we have one like in general in segmentation we want to like most important how much our mask with the ground truth. Like best metric for that is IOU, interesting of union. We use this because our is 72, like 19 layer call 68. For that we found
my
it is
suggestion
like,
is that please watch out for the noise analysis before pre-processing of the ultrasound images. Okay. It's play a very vital role because its speckle noise is a multiplicative noise. It can be added at any time in the system. Okay.
Okay, sir.
Okay. Thanks a lot. Very good. Thank you.
Thank you, sir.
All right, thank you. Now I'd like to call upon the presenter ID 273, and before starting, please show us your ID.
Am I audible? Hello?
Yes, you are.
I think this is my ID.
Can you bring it closer to the camera a bit? All right, thank you.
Is it visible?
Yes, it's visible.
So good morning, respected session chair. I am Dr. Diganshu Asti from Electronics and Communication Engineering Department, GLA University Mathura. Today I am here to present my paper in 12th International Conference on Signal Processing and Integrated Networks. And my paper ID is 273. And my topic is related with copyright protection of Nifty images with NFIS based optimization. So these are the presentation layout, introduction, contributions, existing solutions, proposed technique, results and discussion, comparison of result, conclusion and references. So one of the main concern of the telemedicine applications or telemedicine healthcare services is the copyright protection of the digital images, which we have transferred from the receiver end to the doctor end. So, but the transfer through the communication channels suffer from very illicit activities, like they have there are several leakage in the vital information by the intruders. So the copyright protection and the integrity protection of these information is a significant task to increase the security of the data which we have shared to the communication channel. So digital image watermarking can be used for the protection of copyright of medical information. So the process of hiding copyright information into the digital signal or digital images which we have shared from the receiver, from the sender to receiver end, is known as digital image watermarking. This technique is used to confirm the identity of the owner or the authenticity of the digital assets. So digital image watermarking can be widely used to protect the communication channel, to protect our shared image, to protect the copyright of the digital content and the broadcast tracking also. So this is the basic structure of medical image copyright protection framework. There is one input image which we have to share through the unsecured channel. So first of all, we have to take the identity of the patient or any other copyright logo as a watermark image. Then we have to apply a certain kind of watermarking technique to watermark that input image and then share or transmit that watermark image to unsecured channel. And at the receiver end, there are two types of receivers are present. One is authorized user and another one is unauthorized user. Authorized user have certain kind of key. With the help of that key, it will retain or get back the watermark image back for the confidentiality protection or integrity protection. So this is my contribution. First contribution is there is an effective combination of RDWT and MSVD is used. As RDWT is shift invariant, so it produces the better robustness against various kinds of attacks. And MSVD is better than SVD as it is better in computational complexity term. And MSVD also provides the better visual quality and resilience, that is imperceptibility. The second contribution is NFIS based optimization. There are several kinds of meta heuristic and other kinds of optimization are present, but in this approach, NFIS optimization technique is produced or used. NFIS optimization is employed in the proposed technique to improve the system performance, and it is shown in the result section that it enhances the performance better way. And the next is feature authentication using binary robust invariant scalable key points. So this is very important aspect of our contribution. That is when receiver receive the image. So the authenticity or the verification of the features of the image is very vital aspect for imperceptibility of the image. So this is done by using binary robust invariant scalable key points. And the last one is comparative analysis, and it shows the work is compared with the reference 1, 2, 3, 4, and 12, and it clearly shows the superiority of the robustness and imperceptibility in terms of robustness and imperceptibility. So these are some recent literature surveys. In the first, the main purpose is to provide the blind watermarking image. Then the technique that uses GWT and DCT. But in this technique, there are several kinds of attacks, like geometric attacks, in which the imperceptibility is not up to the mark. In the next literature, they have used DWT and block-based SVD. But SVD may suffer from the false positive problem, so this is the major concern in this technique. And the next one, they also use DWT, but DWT is slower in comparison with other wavelet transforms. And they further used meta-heuristic technique, which is slower in comparison with NFIS. And the next one, they want to optimize the imperceptibility. And for that, they have used DWT and SVD. But the same problem, DWT and SVD combination is computationally inefficient. And in many of the attacks, like geometric attack, shearing attack, it produces less imperceptibility and robustness. So this is the proposed technique in which I have taken the nifty image of size 256 cross 256 as the input, and in which there are 21 slices are present. So for that, I have taken one slice from the image. I have applied RDWT to that. After that, I have calculated the entropy of all the subbands, and in that we have to choose the suitable subband for embedding, which gives the medium entropy, neither too low nor too high, to balance the robustness and imperceptibility. And lastly, we have applied the MSVD to low high and high low subbands to generate the dominant component from that. And the identity of the patient is divided into two parts to further enhance the integrity of the proposed technique. The same techniques are applied, that is RDWT is applied, and again MSVD is applied. And by taking the suitable scaling factor or optimized scaling factor from the ANFIS, that is Adaptive Neural Fuzzy Inference System, we have to add both the dominant component of input image and watermark image. And after that, we have to apply inverse MSVD and inverse RDWT to get the watermark image. And as far as extraction is concerned, the reverse process is applied to the extraction. That is, first of all, RDWT is applied, then MSVD is applied to get the modified dominant component. After that, we have to apply the inverse embedding by taking the same optimized scaling factor. And at the end, we have to combine both the parts of the watermark image to get the combined extracted watermark image. And this is the NFS based optimization technique in which variation in image per pixel and entropy is taken as the input to the fuzzy inference system. And after taken as the input to the fuzzy inference system, we have to create the data set with respect to the VIPP and entropy. And with respect to that, we have calculated the scaling factor. And by the help of these data set, we have to train our adaptive neural fuzzy inference system. And after the training, the adaptive in the testing phase, the adaptive fuzzy neural system will give the optimized scaling factor. And these are the rules which we have created for entropy VIPP, that is variation in image per pixel. And this is the testing data output of the NFS. And as far as result concerned, the highest PSNR value which we have obtained is nearly 52 dB, and SSIM is 0.9999, and the lowest mean square error is 8.1 into 10 to the power minus 6, and KLD is 0, and JSD is 0.0024, and NCC value is 1 without attack. These are the slices, 21 slices, which have taken for the input. And these are the results, that is PSNR value, SSIM, KLD, NCC, MSE, and JSD. JSD is the optimized version of KLD. And these are the results without attack for 21 slices. And these are the results against various kinds of attacks to check the robustness of the technique. And in almost all the cases, the value is greater than 0.9, which shows that the extracted watermark is extracted back very efficiently. And this is the binary robust invariant scalable key point feature verification, and with and without attack. And it shows that the major features of the input image and the watermarked image, after applying the rotation also, it doesn't changes. So the technique is more robust and imperceptible in comparison with other techniques. This is the comparison. I have compared my result with the references which are given below, and it is clearly visible that the proposed work is having a much higher PSNR in comparison with other techniques. And these are the comparison of NCC against various kinds of attacks. And this is the comparison of embedding capacity. So in the proposed technique, the RDWT MSVD based efficient combination is used, which enhances the robustness and imperceptibility effectively to balance the properties of the any image watermarking technique. So here NFIS optimization is effectively used to optimize the scaling factor effectively. And it is clearly visible that the resilience and imperceptibility is better in comparison with other techniques. Feature authentication is also successfully implemented for the developed technique using binary robust invariant scalable key points authentication approach. And our technique surpasses having the percentage improvement in visual similarity is 21.24%, while in resilience is 12.13%. So in future, the proposed technique can be further integrated with other artificial intelligence technique in the embedding process also. These are the references which I have used. Thank you.
Okay. Divyanshu, I have only one query. So you have done with the NFIS optimization. Can you set the clear advantages of other meta-heuristic approaches over this NFIS? What are the advantages for NFIS over other meta-heuristic approaches?
Good morning, sir. Sir, in the meta-heuristic techniques, we have to create a certain kind of equation based on the performance matrices. But in the NFIS-based optimization, we have to choose the properties of the images, like variation in image per pixel, entropy of the image, and there are other kinds of roughness texture component. So this way, it will better generalize the technique. And the second advantage is it uses the hybrid learning approach. That is, it combines the back propagation and also uses the gradient descent to lower the error. And the next advantage is it is adaptive in nature. Once we have set the rules, then based on the properties of any kind of image, it will generate the optimized scaling factor in the better way. And the last one is, it is faster. It has faster convergence in comparison with other techniques because it takes lesser data set for training.
Okay, fine. Very good. Okay. Thank you. Very good work. Okay. Thank you. That's from my side.
Thank you, sir.
All
Nelly,
right,
sir?
thank you. Now I'd like to call the paper ID 274.
So, is this okay?
Are you visible? All right, thank you.
Yeah. Hello everyone. My name is Bhargav Aditya and I am from Andhra Pradesh and I am currently pursuing my BTech in VR Siddhartha Engineering College. And today I
Can
am
you make
in
it
the
full
12th
screen? Okay,
International.
okay. Listen first. Can you make it full screen? Aditya, Bhargav, can you make it full
Yes.
screen? Start from the
Yeah,
first
yeah.
slide onwards. Okay, not in mid. Okay.
Okay. Is it good, sir? Is
Make
it
it full
visible?
screen. Make it full screen slideshow.
Slideshow. Yeah, it's in
Just
full
go at the
screen.
bottom and click on that icon. You will have a slideshow.
No, I think I'm getting. Yeah, just a minute. No, is my PPT visible?
Okay, you may proceed with this only. Okay, you may proceed.
Yeah, thank you, sir. Hello, good morning, sir, and good morning, all my co-presentators. As I said earlier, my name is Bhargav Aditya, and I am today in the 12th International Conference of Signal Processing and Integrated Networks. And the research that I have done is in the field of remote sensing, and I have been titled this research as Chain Detection Using Multispectral Remote Sensing for Urban Monitoring. So let us dive into our topic. So today I will be covering all these problem statement, objectives, literature, methodology, architecture, results, result analysis, and the societal impact, as well as the fieldwork and references that I have been using in my project. And coming to the problem statement, in today's world, rapid urbanization is one of the biggest problems that everyone is facing. And because, there are lots of cities and lots of places that are undergoing rapid changes, rapid extensions, and rapid urbanization because of due to various reasons. It may be due to jobs, it may be due to climatic conditions, etc. And monitoring these changes is very difficult nowadays. So strategies are needed to be integrate ecological consideration into urban planning. And the main problem comes when urban planning comes sort of Hello. Am I audible?
Yes, you're
Am I
audible
audible?
now.
Hello. Yeah. Thank you. So what are the methods that today people are using and or today government officials are using are traditional methods. Like they send particular set of people to particular place and they say them to take all the measurements or just to observe. Like we need manual intervention to observe all these places. So I thought that it would be good if there is an automated model which always depicts all these changes rapidly. So I have come up with an idea of this chain detection model. And the objectives of this model are correction of multispectral images with required band composition from Landsat and satellite. So as I mentioned, the images that I will be using for this classification are from Landsat and satellite. And of course, they are multispectral images and they are consisting of 5 bands. And to prepare an automated model which makes the multispectral data as input and produce a change map, and also to produce a change matrix from the produced change map. And the outcomes of this project are an automatic chain detection model, as I said earlier, which produces a change map displaying the changes within the given inputs, and also a change matrix along with the change map that displays the change percentages in each land cover type. So I think it's a bit confusing. Let me dive into more deep into the topic so that you will be getting much more clarity. So these are some of the literature, or these are some of the papers
Excuse
that I
me,
have taken as my
sir.
reference.
I'm sorry to interrupt, but your slide is not working. I think it's stuck on the first page itself, cover
Yes,
page.
your slide is not changing. Okay, you should change it. That's why I'm saying make it full screen, then you should proceed.
Is it okay now? Wait. Is it okay now?
No, it's showing the first page only.
Uh,
Can you try resharing it, like stop once and then present again?
yeah, I am doing that. So is it good now?
It's not full screen.
Yeah, I think my computer's not supporting this.
All right, then you can show it separately, like this.
Okay, is it good now? Is it good? Is it
You
visible?
may continue. It's not full screen, but it's visible. You may continue.
Yeah. I'm sorry, guys. Kindly bear with me. I think I have some technical error right now. Please bear with me. And so, yeah, let's get into our topic. And this is the literature survey. These are the papers that I have taken as reference to do my project. And you can see the papers that I have been taking from 2023 and 2024. And I have listed what was the work done in the paper and what was the algorithms they have used in their study. And I created an abstract out of the findings that I have done, and I have also written the key findings for each paper. Yeah. And now coming to my methodology, I have my methodology in 7 phases, where phase 1 is the collection of data, that is collection of Landsat images that are captured by the Landsat. And in phase 2, I will be calculating NDVI, NDWI, and NDBI, where NDVI stands for Natural Differential Vegetation Index, WI for Water Index, and BI for Built-up Index. NDVI is used for classifying vegetation land cover, WI for water land cover, and BI for built-up area, where built-up area include buildings, roads, and all the man-made structures. And coming to phase 3, I have written a function which would classify the land cover based on the indices calculated. Let me explain it with you with clarity. Suppose I have given an image as input to my algorithm, and it shows that at particular pixel the NDVI value is greater than 0.5. Then the particular pixel is classified as vegetation. Sorry, it is classified as forest. And if the NDVI range is between 0.1 to 0.5, then it is classified as vegetation. If it is less than 0.1, then it is classified as barren land. And if the NDBI value is greater than 0, it is classified as built up area. NDWI, it is classified as water. Calculation of land cover percentages based on the total land cover that I have taken. I have been calculating the percentages by a simple formula where we use sum of built up area.
Excuse me, sir. I'm sorry to bother you again, but due to time constraints, I would like you to kindly wind up.
Yeah. Okay. Then I will be skipping to my methodology. Yeah, this is my architecture diagram that I have used, where we will be taking two images from different timelines, two multispectral images to be precise, and I will be calculating all the three indices, that is NDVI, NDWI, NDBI, and after that I will be segregating the land covers. As you can see, I will be giving different colors to different land covers: built up, water, forest, vegetation, and barren land. And now I will be combining these two land covers, and we will be presenting the major changes that I have been observing in the land cover shifts, and I will be generating a binary change map, and of course at last I will be uh, like making a change analysis model where a graph is displayed. And these are the results that I have got, and the area of selection is Penamaluru, a region in Vijayawada, Andhra Pradesh itself, where I have taken a image of Penamaluru from 2016, a image of Penamaluru from 2023, and I could successfully generate a change map which showed the different changes in built up water, vegetation, forest, and barren land. And you can also see the change matrix below, where it shows the percentage of built up area in image 1 and percentage of built up area in image 2, and what is the change that have been observed from 2016 to 2023 in the region of Penmalur. And I could observe that there is a lot more change in built up area and vegetation, where there is a drastic fall in vegetation and an increase in built up area. So I could conclude that most of the vegetation land that was used for vegetation was like reused for constructing built up area. And this is the result analysis where I have presented my change map, the change matrix that I have got, and I have plotted this change map for giving a pictorial representation to these changes. And this is the societal impact, and we would have an enhanced urban planning. Now, if when you look what is the use of this model, so there is no need of human intervention. You just need a photograph of the same place from two different timelines, and you can directly give it to the algorithm, where it will be giving you all the changes, which is easier for government officials to make urban planning, and also enhanced water management during the time of floods or during the time of scarcity. And to know that whether the results that I have got are true or not, we have conducted fieldwork. First, we have taken the change map and selected particular areas where there is a change being displayed in the change map, and we went to that area and we actually got the change that was depicted. Like if it has depicted the particular area as built up area, and naturally that area was getting into build up. Initially it was in vegetation, then it went to build up. And these are the fieldwork photos that we have performed, and these are the references that I have been using in my project. Thank you.
Okay, Adit, sorry to say that we are not able to see your any work by the presentation. Okay, your slide were not moving, your slide were not shifting. So just I have one query
Yes,
regarding
sir.
your topic. How do we classify how do we differentiate between a multispectral image and a conventional RGB or grayscale image?
Yes, sir. In like if we take a photo from our camera, the image that we get is an RGB image. Actually, this RGB is red,
No,
green,
no,
and
no, no.
blue.
Just listen my question first, then you answer. I'm just asking what is the thin line of difference between a multispectral image and the conventional RGB or grayscale images. I'm not asking the process. How do we acquire them? Okay.
Yeah. Sir, in multispectral images, we have more number of bands, sir. Whereas in
We
RGB,
have
we
more
have
number
only
of.
three bands.
Okay, so if I give you a conventional RGB or YCBCR color image, and if I say you to form a multispectral image, whether it can be done or not.
No, sir, it cannot be done. When you give a RGB image to me, we also need another bands which cannot be acquired.
Okay. On second thing, one which tool you have simulated this work? On which tool you have compiled this work?
I have used Google Colab for writing all my codes, sir.
Google
And the
Colab.
images from Landsat 8.
Okay, fine.
The images I have acquired from Google Earth Engine.
Okay, fine. Thank you. That's it from my side. Okay, thanks a lot.
Thank you.
All right. Thank you for your presentation. Since your PPT was not visible, would you be able to share it with us on the mail shared with you?
Okay, thank you. I will be doing that.
All right. Thank you. All right. So that was the last presenter. I would like to thank each presenter who presented the paper and their hard work. It was a really fruitful experience. I would now request Dr. Anil Kumar Shukla to present sapling to Dr. Priyansh Khare and the certificate of a token of appreciation for being the session chair. Thank you so much, sir. Your presence really lifted the entire.
Thank you, ma'am. Thank you.
Thank you so much, Dr. Priyank, for sparing your valuable time for SPIN 2025.
Okay.
Thank you so much once again.
Okay.
Thanks to all presenters.
Okay.
All right, paper presenters, your certificates will be sent to you via email shortly. Thank you for your valuable contributions. I would like now Dr. Priyank Khare's permission to close the session. Been a privilege to have you all today, and this session is success.
Okay. Thanks to the organizing committee of SPIN 2025 for providing this opportunity to session and share regarding on the topic of image processing and video processing track. And thanks a lot. And it was a very pleasant and nice session to hear the very noble works from all across the globe of this world. Okay, thank you once again for providing me this opportunity. Thanks a lot. Thank you.
All right. Thank you everyone for being the session chair. Now the next session will start at 11:45.
due to some emergencies, she is not available. So her recorded video PPT will be going to be played. Thank you once again.
Dr. Andersen is a professor at Aalborg University, Denmark, where she serves as director of the Center of Rehabilitation Robotics and leads the Neuro Rehabilitation Robotics and Engineering Research Group. Her work focuses on developing assistive technologies to enhance the quality of life for individuals with severe disabilities. One of her groundbreaking innovations is ITEM, a device that enables paralyzed users to control assisted devices using tongue movement, leading to the founding of TKS-AS. She has also supervised 9 PhD students as the main advisor and played key roles in PhD defenses and academic matters. Dr. Anderson is actively engaged in academia, serving on the academic council at AAU, the HST board, and as program co-chair for IEEE EMBC 2025. She also holds an honorary professorship at Amity University and contributes to the policy discussions on welfare technology in Denmark. Her work aligns closely with several United Nations Sustainable Development Goals, reinforcing her impact on global innovation and inclusivity in healthcare. As I mentioned, Dr. Lotte Anne Sandhyasen Stout is not available, so a PPT is going to be played on her topic, Introduction to Rehabilitation Robotics, Research at Center of Rehabilitation Robotics.
The center Thanks for the opportunity to speak here today, and congratulations with this very nice event. I am Lotte Andreasen Strøb, and I am a professor at the Department of Health Science and Technology at Aalborg University, where I am the day-to-day director of the Center for Rehabilitation Robotics, and I will give you an introduction to our research at the center. Aalborg University is located at northern Denmark, as you can see here, and In Aalborg, we have approximately 120,000 citizens in the town Aalborg, and at the university we have around 20,000 students and around 2,000 researchers. The center is an interdisciplinary faculties at Aalborg University, and it has an interdisciplinary network including users, researchers, clinicians, industry, and international partners, and you are also welcome to join the network. The center is funded by the Danish Louis Hansen Foundation, and we have also projects funded from other places like the EU and the Danish Research Council. Our mission is to develop interfaces and robotics to help users with disability to increase their independency and also to reduce workload and injuries amongst clinicians, and further to support users with disabilities to become active members of the workforce and thereby increase their quality of life. At the same time, we aim to create data for new rehabilitation. We have different center-related projects where those shown here in bold are the ones I will introduce today. And I will start with our research on tongue intervals. The tongue interface that we have developed is called the iTone, and it consists of a denser material-like plate with sensors which are placed at the heart payload. The signals from the sensors are transmitted wirelessly out of the mouth to a central unit which connects wirelessly to a computer, a powered wheelchair, or a robot. The sensors are activated with a metal probe shown here that is pushed around in a frame by the tongue. When the tongue pushes the activation unit so it touches the sensors, it works like pushing a button on a keypad. The system is available as the product iTone, which can control wheelchairs and computers, and we have also done research on controlling drones, prosthetic and assisted robotic manipulators, and exoskeletons. We have performed a usability study on reading and speaking, and the results have shown on a scale from 1 to 10, noticeable to 10, which was unacceptable, that the ratings were in the level of 1 to 6 with an average of 2.6, indicating good usability of the system after 3 days. After this study, we performed a pilot study on tongue controlling a robot, where we related the 18 sensors of the iTone that are shown here as circles to the different motions of the robot. And then the user had a visual effect that showed which sensor was activated by the circle red, as shown here. You can see an example how the iTone can be used to control a robotic manipulator in this video, where a woman who's paralyzed with both arms and legs used the tongue to control the robot. You can see the visual feedback here, and she's trying for the first time to pour water in a cup. And this is the first time in 19 years. And she was able to do this in the first attempt. And she has been very supportive with feedback on the research. So to create all advanced tools, we are interpolating the signals from the sensor and get a resolution at about 1.5 meters, which can be classified as AI, so we can design many different buttons and joysticks on the total interface, as you can see. We are using this research on combining tone, brain, and muscle signals to control assisted robots, so the control system can be adapted to a user that gets more paralyzed as it ages. This that if you have a whole panel of images of tone interface texts, that each flashes with different frequencies, and you can see then you can see in brain signal which frequencies and just as shows. You can look at the upper picture to select that, for example, then you detect that signal. And then you can activate the upper sensor area with the tongue and make the robot move. Afterwards, you can do the new field, so you can choose a new robot. This is shown here in this video where Rasmus is wearing a headband with electrode vision. And when he looks at one of the flashing fields, he selects it. As you can see on that. And then with his tongue, he can activate one of the two robotic movements in the field, and then he can continue until he has poured water into the cup. We are also developing the exotic, which is an intelligent tongue control exoskeleton arm with 5 degrees of freedoms, or 5 joints, you could say. It works in such a way that a user can tongue control the arm towards, for example, a glass, and then activate an automatic grasp command with the tongue, so that the hand automatically comes close enough to the glass to grasp it. The exotic is based on interdisciplinary research in order to incorporate requirements from both engineers, users, clinicians, and the society from the beginning of the development. And the exotic is intelligent, so it can detect what the user tries to pick up, for example, a cup, and then automatically move the exo towards it to grasp it, as long as the user still activates the tongue control system. So it's shared control. And you can see this in
The exotic exoskeleton relies on a rigid structure driven by small motors located along the length of the exoskeleton, together with a soft exoskeleton glove. In total, there are 5 degrees of freedom, including hand opening and closing. The upper arm rotation and wrist joints use a relatively special joint based on a semicircular guide design that twists the arm and allows for a more compact design, as shown in the video. For this exoskeleton, ergonomics was an important factor, as individuals with complete paralysis are prone to exhibit an autonomic response to pressure and irritation applied to the skin. Therefore, the exoskeleton has a soft attachment to the arm. As such, the arm is simply carried by 3 ergonomic braces located along the arm. The first problem you encounter when developing assistive technology for individuals with complete bodily paralysis is that they cannot use a standard interface technology like a joystick. Therefore, our group developed a wireless tongue control interface some years ago. The interface looks like a palate brace and is put in the roof of the mouth. The bottom surface of the device can sense the position of ferromagnetic materials, like a tongue piercing, which is exactly how we command this interface. 18 tiny coils are embedded in the brace that detect whether a ferromagnetic material is in the vicinity of the coil. In practice, this enables individuals with complete bodily paralysis to fully control 9 degrees of freedom directly and continuously in an invisible manner.
Because the activation unit or the pedal activating the sensors is now mounted in a frame at the sensors. This makes it more easy to use in a clinical setting. So we have tested the exoskeleton with users with spinal cord injury, as you can see here. And they were also able to tongue control the exoskeleton arm to pick up bottles and to pick up, for example, fruit for snacking. And also they could use the intelligent part of the system, so they semi-automatically controlled it. And finally, they were able also to switch on buttons with the exoskeleton. So 10 paralyzed users participated in these experiments, and all of the users with the relevant disability would like to use a system like this in the future. And one of the participants even felt that it was like using his own arm again. So this motivated us to continue working with the exoskeleton and try to integrate the combination of brain, muscle, and tongue control to adapt to a progressive paralysis. And here in the video, you can see an example of a tongue-brain controlled exoskeleton where the brain signal is used to switch between the possible commands that you can control afterwards with the tongue. And in this way, the user can control the exoskeleton to manipulate the bottle. An example on our research on therapeutic robots is the EU project Robot SAS, which is together with a local robotic company, Life Science Robotics, and RRD from the Netherlands. Our task was to perform research and development on the Assist as Needed rehabilitation module, where we measure a weak muscle signals from a bedridden stroke patient and then use it to trigger electrical stimulation of the leg muscle to get a strong contraction for exercising during robotic assistance, as you can see here. These electrodes in the middle measure when the patient tries to contract, and then the electrical stimulation starts from the bigger electrodes. And this helps the patient to stretch the leg against the robot. So that was a brief introduction to our work. I would like to thank all the contributors to the research. And again, thank you very much for the opportunity to speak here today. And thank you very much for listening.
I would like to thank Dr. Anderson for such an informative session. I would like to invite Dr. Anil Kumar Shukla to present a certificate to Dr. Lotte N.S. Ambiatus Proud as a token of our appreciation.
Thank you so much, madam. for this interesting lecture. Since she is not present in this session, so this message is being conveyed to Professor. Thank you so much, madam.
Thank you for being a part of SPIN 2025, ma'am. It is a great privilege to have Dr. Amit Kumar Chaudhary with us today. I would like to invite Dr. Anil Kumar Shukla to present a sapling to Dr. Amit Kumar Chaudhary.
Thank you so much, Professor Amit Chaudhary, for sparing your valuable time. Thank you so much.
Thank you, sir. Am I audible?
Dr. Amit Kumar Chaudhary is currently an assistant professor in the Department of Electrical Engineering at BIT Sindri, Dhanbad, and has previously held faculty positions at Jabalpur Engineering College, NIT, Kurukshetra, and IIT Varanasi. He holds a PhD in Electrical Engineering Control System from IIT Varanasi and MTech from NIT Kurukshetra and a BTech in Electronics and Instrumentation Engineering. His contributions to the control systems and automations have been widely recognized, including the Best Paper Award at IEEE BitCon 2024, the IETE Gowrie Memorial Award, and the CSIR Foreign Travel Grant to present research in Japan. He has also received travel support from SIAM for conferences in Switzerland and has been honored as the best volunteer at IEEE BitCon 2016. Dr. Amit Kumar Chaudhary is an active member of IEEE, SIAM, IET, and ACDOS, contributing significantly to research in model order reduction and control system automation. With a commitment to academic excellence and innovation, his research continues to impact both industry and academia. Welcome once again, sir.
Hello, Rachit.
Yes, sir. Good morning.
Good morning. Is my voice audible?
Yes, sir. You are audible.
Okay, thank you.
Yes, sir. Sir, would you like to call upon the paper presenters yourself, or would you prefer if I did it?
I'll be comfortable with both, but you volunteer.
Okay, thank you, sir. I would like to call upon the presenter from paper ID 392 to present their paper.
So much. Can I confirm if I'm audible?
Yes, you are audible.
Thank you.
You may please show your presenter ID once and then continue.
Okay. Do I just show it on camera? This is my ID.
Yes, it's we'll just hold it once again. Yes, thank you very much. Now you may proceed with your presentation.
Can I confirm if my presentation is visible?
Yes, it's visible. Thank you.
Thank you. Good afternoon to everyone present over here, and thank you so much for this opportunity to SPIN to allow us to present our paper. I am Sharanya Vanraj Stambi from Amrita Vishwavidyapeetham, Bengaluru. I'm currently in the Artificial Intelligence Engineering branch, and I wrote this paper along with a few of my teammates, Aishwarya, Kavya, and my mentor, Niharika ma'am. So our paper is basically automata-driven fire rescue bot, and we're using NFA and Turing machine for this purpose, and it's for efficient path finding. NFA is basically non-deterministic finite automata, and TM is Turing machine. This is the agenda. First, I'll be presenting our problem statement, followed by the introduction, then the methodology that we have used. Then I'll be showing why we have used NFA and TM, as well as the implementation and testing of both NFA and Turing machine. Then we have made a Pygame simulation of the same to showcase a visualization. I'll be presenting that as well as a future scope. So the problem statement. Now we have built a fire rescue bot, and NFA, all types of automata are really well used for pathfinding scenarios, and we decided to think of a application where it would be needed the most, and we thought of fire rescue bots. Now, why do you need a fire rescue bot? A situation in which there's a fire scenario and you cannot be sending human personnel out into the area, and you would need a bot to handle it. It could be risky scenarios, navigating through walls, fire, in a hazardous environment with paths being blocked. So for this particular purpose, we would need a fire rescue bot. An automata basically is a computational or mathematical model that is best used for pattern matching and things like lexical analysis. So it basically automates the process of decision making. So the approach that we have taken is firstly finding the possible states that the bot can be in, like facing a wall or facing fire or reaching the goal state, and then the actions that it's supposed to take. Then we decided to implement this and formulate a diagram for this, followed by creating a transition table of what we have implemented in the diagram and testing it with multiple possible scenarios. Now, there are two types of finite automata. One is non-deterministic and one is deterministic. Why did we go with non-deterministic finite automata? Basically, in NFA, you can have multiple sort of transitions between one state to another. But in DFA, you can only have one. And the point being that you have less processing required because of the same reason, as DFA requires all types of inputs to be handled. But in such a scenario, we do not need all possible movements at the same time. So we go for NFA. So this is the methodology that we have in our paper. First is designing the automata manually, then testing it on an application called JFlab, which is mainly meant for automata. Then creating a Pygame simulation, which is a Python module to show how the visualization would look in a real scenario. And then we compare both of them. So as I mentioned before, NFA and TM is used for real-time decision making so that a lot of scenarios can be taken into context. Then obstacle detection and avoidance, such as walls and fire. And then a dynamic environment where you will have to take decisions based on each step and it'll keep changing. To explain what NFA and TM is, in case anybody does not know, non-deterministic finite automata is the one on the left side. What you can see over here is Q0, Q1, and Q2 are different states. So this is for a regular expression type of scenario where A is the input coming from the first state and B is the second input. So in this particular scenario, the string that you would get is AB. Say I have a transition from Q2 to Q0 again, then that regular expression would be AB, 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 and so on. So this is what NFA models. Instead of this, we'll be instead of Q0, Q1, Q2, we'll be having our fire state, wall state, or such scenarios. In Turing machine, it's a more complex model in which you can actually store what you have memorized in the memory of Turing machine. For example, if you're writing A and B, in NFA does not get stored, but the number of A's and B's gets stored in Turing machine, and you can move backwards as well as forward. So for the states that we have defined, we had to think a lot about it, and we came up with start, free, fire, extinguished, fire, wall, goal, and dead state. And then the inputs that we have taken is basically what we're sensing is that there's a wall adjacent, so adjacent wall, adjacent fire, adjacent free, extinguish, that it has to be extinguished, avoid wall, all adjacent walls, if all adjacent walls are on all four sides, and if there's a goal adjacent. This is the quintuple. Basically, this is how NFA is defined. So Q states all the states in the NFA. And the second one is basically the sigma notation is all possible inputs. Q naught is the first state, which is our start state. F is the final state, which is goal. And the middle transition is basically all possible transitions. These are all the possible transitions, and if I have to take a few as example, it would be start, and if you face adjacent fire, if adjacent fire is the input, then fire will be the next state that you'll go to. For example, if free is the state, and then adjacent walls is what you're taking as input, then you're in a wall state. For example, if you're in a state called fire, and you go to take input as extinguish, then the state that you'll end up in is extinguished state. So this is the transition table. This is how it is simulated on JFlap. JFlap is basically an application, and it basically shows all the types of states and the transitions from one to another. So if you're in a free state and adjacent is free, you're again ending up on a free state. For example, if you're on a start state and goal is adjacent, you'll end up in a goal state. The same thing can be tested in the JFlap application, and we put in a few scenarios such as adjacent walls, then adjacent goals, and it got accepted. For example, if we put a scenario that does not exist, like adjacent fire, adjacent free, adjacent fire, extinguish, adjacent walls, and adjacent walls, it gets rejected because this particular input scenario is not possible. The same thing if we implement it using Turing machine, we have the same states but a little bit of a different input notation, and that you will see in the upcoming diagrams. Turing machine uses a little bit of a different state table. So it's basically the right symbol, the move direction, because you can move right or left. Right now we have implemented how it goes from going from a start position to saving a person in the fire. So we only move in the right direction. So right or stuck, which is R or S, is the possible move directions. Next state is the state that we end up in, and right symbol is basically our input, like I had explained. So start state, if you're this is in a free state, you move right and you'll end up in Q1 state, which is free. So this is how TM's transition table looks. This is the simulation in JFlap for the same. And for example, if I have to take the same scenario that I explained in the previous slide, if you have to take a right and go from a start state to a free state, you will end up in free. So this is how it has been implemented. And the same thing we have again tested using the JFlap application. So if this is a free wall, fire, free, and goal state, and it has been rejected. So just to show a visualization of how it occurs, we have created a Pygame scenario in which all these black boxes are the walls, and these red boxes are where fire is. The bot moves in such a way that whenever it reaches a wall, it takes another path to go to a free square. And if it's in a square that has fire, then it extinguishes it and it turns into such a gray state. And then according to the rules of NFA and TM, it finds a path and reaches the goal state, which is the P state over here. So the future scope that we have is right now only what we have implemented is it going to the goal state and capturing or saving a particular person stuck in the fire. But the same thing can be done by saving by going back to the goal state. So that is one of our future scopes. That is a trace back route. And to make the situation more dynamic, such that if there is no wall and some obstacle falls, so then that is a new scenario that gets added dynamically. So this can be generalized for more domains, not just fire rescue robots. So that would be our third application for the future scope. That is my presentation.
Thank you very much.
These
Anyone from the you may continue, sorry.
No. Continue. No, it's okay. I just wanted to mention that we surveyed 17 papers and those are mentioned in the references. Thank you.
Thank you very much. If anyone in the audience has any questions, you may kindly unmute yourself.
Yeah, Saranya.
Yes, sir.
Yeah, this is Amit this side.
Yes, sir. Hello, sir.
Hello. I have only few questions.
Yes, sir.
You had a very nice presentation and
Thank you,
very
sir.
calm while presenting your presentation. So it's a good attitude.
Thank you, sir.
Be soft and calm while delivering your presentation. It's nice. So
Thank you, sir.
good. Before coming to question, is like the boat you have designed is a fire rescue boat, no?
Yes.
Okay. So what would be the maximum range of fire temperature that your boat can bear?
So any right now, because we have just set the state as fire state, so any amount of fire would be considered as fire state. It's just a particular notation, just fire state.
This is not means just for simulation purpose you are doing this.
Yes, to design an automator in such a case that in a real life scenario, if a bot is there in the position it faces fire, then it will decide according to our automaton which route to take.
No, but okay, that is good. But if it is moving, if any hardware project is proposed on this project,
yes,
then
yes.
What would be the maximum temperature? Because when fire is there, then it could be thousands also, no?
Yes, sir. So, for example, if it is in a hardware scenario, and we could consider having image sensors in such a case that how much ever fire is there, this particular automaton should be able to handle the scenario.
How much temperature means like any amount of range it could handle.
Any amount of range, yes.
Okay, this is very vague answer. Try to be strict with this.
Okay, sir.
Okay, and one more question is like one application you mentioned is JFlap.
Yes.
What's the full form of that?
I'm not sure about the full form, sir, but it's an application used only specifically for all types of automata.
Okay, but it should have no. There should
yes,
be.
Sir, I'll look into the.
And you're working on that. You have shown all your presentation using JFlap, whether it is NFM or TM. JFlap you have been using.
Yes.
Okay. Anyways, work on this and all the best.
Thank you, sir. Thank you so much for your opinion, sir. We'll keep it in mind and research into it.
Okay. Thank you.
Thank you.
I believe the audience does not have any further questions.
Yeah,
so, yes, sir. Thank you. So now I would like to call the presenter from paper ID 439 to present the paper. Mr. Arun.
Hello.
Yes.
Good afternoon. Good afternoon. I am audible?
Yes, you are audible. May you please show your presenter ID?
Yes.
Complete ID. Could you hold it a little up?
Okay, well.
Okay, thanks. I may proceed with your presentation.
Okay. It is audible?
Yes, it's visible.
Okay.
You are audible.
Good afternoon to all the dignitaries. Myself Arun Kumar. Currently, I'm working as assistant professor in discipline of history, SRM University, AP. In this paper, two more author. First is two more co-author. One is Anil Kumar, and second is Amit Vishwakarma. They are working in assistant professor in IIIT Jabalpur. My topic of presentation is multi-level crop image segmentation using two-dimensional histogram on Raspberry Pi. These are my table of content, like first introduction, motivation, third one methodology, result and discussion, conclusion and future scope, and references. First introduction. So image segmentation is a pre-processing steps, and the goal of image segmentation is to partition an image into different region based on their pixels value, their colors, variation, and to extract the meaningful information from this image. It has various application in different area like medical domain, remote sensing, agriculture domain, etc. In agriculture domain, nearby the vicinity, there are various crop images. They are having their broad intensity range of color. Their background is complex. The vagueness is present. So the thresholding technique, the multi-level thresholding technique of such crop images is very challenging task. So by incorporations of these techniques like image segmentation techniques in the field of agriculture, it will be very beneficial. They will monitor the crop health, their ripeness status, etc. The next slide is the motivations why where they have got motivated to do the work in the agriculture area. So the first is the monitoring of crop health. So near the vicinity of the crop images, they are very in their backgrounds. In the early stage, some of the crop they are affected due to the bacteria, their fungal. So and their fungal. So the crop and the crop health they are deteriorated. Their productivity gets deteriorated. That's why the crop image segmentation technique that will be very beneficial for the monitoring of their health. So because we developing we have done the work on the multi-level thresholding technique where these are based on the intensity values. So based on the segmentation, they very easily they can know the ripeness status of the fruit. So next is the automations. For the large cultivated area, it will be very beneficial to use the image segmentation techniques. It will also identify the disease based on their multi-level thresholding techniques. So in image segmentation, mostly the work has been done. They're based on one-dimension histogram approach. In one-dimension histogram approach, they are basically their grayscale value. So it will not consider the spatial informations. So in two-dimensional histogram, both the grayscale and non-local mean value, they are combined to form the two-dimensional histogram approach, and they will consider the spatial informations. So that's why we have work that are based on the two-dimensional histogram approach. So in this is the methodology. These are the block diagram of our methodology, where first we have taken the crop images like any of the input image. So first it should be converted into grayscale image, and finally the two-dimensional histogram they are combined with the grayscale value and non-local mean value. Finally, our objective functions objective function we have taken at the Raynier entropy. They will maximize the entropy based upon the two-dimensional histogram approach. So Raynier entropy and slim mold, we have taken one of the optimization technique like SMA, that is slim mold algorithms. So both are combined to get the like minimal get the like minimal value, and finally we get the segmented image. So here the input image is crop image we have taken. Here the two-dimension histogram clearly shown in one axis they are grayscale and second axis they are non-local mean image. So finally they are pair of occurrence. The combinations of grayscale and non-local mean they get the two-dimension histogram approach. So here Pij is the two-dimension histogram. This is the normalized value where M and M is the size of the image. So here is a Renyi entropy. They are segmented into different parts. So calculated the Renyi entropy, and finally we get the optimal value based on the Renyi entropy for maximizing this. Next one, the performance evaluation parameter. We have calculated the performance based on like peak signal to noise ratio, root mean square errors, structural similarity index, and feature similarity index. Here a root mean square error where I of I is the original image, where I1 Ij is the segmented image. Next is the result and discussions part. We have taken the two data sets. They are publicly available data sets. In this we have taken the like swarm size. We have taken the three like optimization technique. First is firefly algorithm, second is beta differential algorithm, and our proposed method is slim-L algorithms. So for each of the algorithm, the swarm size and iteration we have fixed it 25 and 200 for the fairness. First, the proposed method we have applied without proposed method we have applied. The result they are showing in table first. In the next slides, these are the proposed methods in terms of PSNR, RMSE, root mean square error, SSIM, and FSIM. Here, proposed method are compared with beta differential algorithm and firefly algorithms, and for different level of thresholding like 2, 5, 8, and 16. Here we see that in most of the cases, like higher the peak signal to noise ratio and lower the root mean square error, the proposed methods have good segmentation results. So for proposed methods, the PSNR value is high and RMSE value is low for all the images we have shown here. For like hardware applications, these results have been verified using the Raspberry Pi, and again these results have been verified using Raspberry Pi. Again, here we see that the proposed method will have the more peak signal to noise ratio, less root mean square error, higher SSIM value, and higher FSIM value for the proposed methods. In next slide, you will see the comparison between the proposed method without Raspberry Pi and proposed method with Raspberry Pi. So here we see that here we see that the proposed method with Raspberry Pi having a lesser result, like less value, lesser than the proposed method without Raspberry Pi. Suppose you see here at threshold level 2, without Raspberry Pi, the PSNR value is 15.68, but we got 14.757 when applied with the Raspberry Pi. So its value is slightly lower, but it's a hardware platform. We have tried to verify it with the Raspberry Pi. In this slide, the conclusion and future scope. So the multi-level crop image segmentation using Renyi entropy and slim-mold algorithms, like we have applied as a two-dimensional histogram, and this is verified using the Raspberry Pi. So first, without Raspberry Pi and Raspberry Pi, in both the cases, some improvements are in terms of PSNR, root mean square error, SSIM, and FSIM will be there. So in proposed method achieves the improvement of 7.37, 5.97, 4.52, and 4.66 without Raspberry Pi at different threshold level like 2, 5, 8, and 16. It also achieves the improvement of 6.48, 6.84, 5.45, and 4.35 of average PSNR value at sustained threshold level. So we have tried for two different data sets, but a limited number of crop images will be there. Only we have applied for to the 6 crop images. In future, we will apply to more than the 6 crop images, more than apply for the larger data sets also, and the different type of crop images. These are the references. Thank you from my side.
If anyone in the audience has any questions, you may unmute yourselves.
Yeah, Arun.
Yes, sir.
Come to your first slide. I don't have any question, but come to your first slide.
Yes, sir.
Yeah. First of all, your presentation was nice. Okay. Only one mistake in this total slide I found is, can you guess that?
Sir, I think my supervisor name?
No, not that. Just a slight error, mistake. Okay, anyways, let me tell you. SPIN 2025 is of Springer, not of IEEE.
Oh, sorry, sir.
So this is called not a mistake,
yes.
This is a blunder.
Yes. I accept this, sir.
Okay. Okay. Thank you, Arun.
Thank you so much, sir. Can I stop here, sir?
Yeah, sure. Rachit, continue with next presentation.
Yes, sir. Now I would like to call upon the presenter from the paper ID 481 to present their paper.
Hello, am I audible?
Yes, sir, you are audible. Can you please show your presenter ID once? Yes, sir, that's fine. Thank you, and you may continue with the presentation.
Let me share my screen. I hope my screen is visible. Is my screen visible?
Yes, sir, it's visible.
Okay. So, good afternoon, everyone. Respected session chair and dear participants, I am Satyavan Jagtap. My paper ID is 481. I would like to discuss my work, that is the state space modeling and observe based fault diagnosis in the buck DC-DC converter. The co-author of this paper is Dr. Dagdu More. These are the contents of this today's presentation: introduction, formulation of state space model, then observer, and then simulation results, experimental results, and conclusion. So, as we know that the switching power converters find wide applications in the industrial, such as motor drives, induction. Let me bring this below. Induction heating, welding, and robotics. There are many applications in the transportation as well, in the vehicles. Nowadays, it is used in the cars and all these things, e-vehicles. Utility system applications like wind energy generation, solar power generation, then the hydrogen fuel, then HVDC transmission. These are the applications of the switching power converters. Then different power supplies, these are employed widely. Home appliances. So these are the many applications, space applications. So the purpose of this of the showing these applications is to understand the some safety critical applications, and where the switching power converters are widely used. So in these type of applications, reliability is the main concern. So what are the causes of these failures? So basically, we'll see the causes of the failures afterwards. But whenever there is any fault in the converter itself, then that may lead into the system downtime. There may be that may results in the economic losses, and also the results in the safety hazards. So what are the different causes of these failures in the power electronic converters? So under the operational and environmental causes, so as we know that the switching power converters, they convert one form of energy into the other form. So DC-DC converters, AC to DC, DC to AC, all these types of conversions are there. So during this transfer of energy or conversion of the energy, so these devices and the components of the converters, they undergo in a high voltages and currents. So due to these very high voltage and current transitions during this conversion of energy, there may be the exceedation of these voltages and transistors, and they may exceed the maximum limit of these voltages and transistors, and that may lead to the failure of these devices and components. So according to the survey, so there is a survey here. So according to this survey, it is found that the power devices are the most fragile components out of these components employed in the power converters. And after that, the capacitor, then gate drive circuits, and then inductors. So for the reliability enhancement, so there should be early fault detection and fault tolerant control also. So fault tolerant control is the remedial actions after the detection of the faults. So operation should be continued, and for that the remedial action is very essential. So this is the necessity of this research work. So there should be a design and development of fault diagnosis techniques to detect the fault online and take appropriate action to provide the content of the system operation with the required performance and safety. So there are the different fault diagnosis strategies. These are the mainly categorized in 5: model-based, signal-based, knowledge-based, hybrid, and active type of fault diagnosis methods. So in the model-based, accurate model of the system is required, and there are some advantages and disadvantages of each of these methods. Then signal-based methods, where the comparison of the real-time faulty signal is done with the healthy signal. Knowledge-based systems, they also require the models. In case of the model is not available, or it is very difficult to obtain the model for the complex system, in that case we can go for the knowledge based systems, where we can use the physiologics and neural networks. And the hybrid method means we can have the combination of 2 or more methods of this, and the active method, in which the external input test signal is introduced into the system to detect the fault. So out of this, I have worked on these signal based methods, and presently I am working on this model based methods. So before going to see this analysis and fault diagnosis technique, so there are basically 2 types of faults: soft faults and hard faults. Soft faults means the gradually degradation of the that component value. So gradually performance degradation due to the device aging. So in case of the capacitor or inductor, so this type of fault is there. And hard faults, those are also called the catastrophic faults, and which are nothing but the open circuit faults and short circuit faults. So open circuit faults, they may be because of the SCF, that is the short circuit faults. So short circuit faults ultimately will end to the at the OCF, that is open circuit fault. Lifting of the bond wires and gating faults. So these are the reasons of the OCF. Short circuit faults, they can be coped with the fast fuse. Now these are the some simulations I have done to understand the effect of the switch OCF and SCF. So this is the basic DC-DC converter circuit. So I have purposely introduced the open circuit fault into this MOSFET. So at this instant, I have introduced the open circuit fault. I have understood the effect of this fault upon the parameters. So how the inductor current is going to vary and how the output voltage is going to vary. Then I have understood the effect of this short circuit fault. So I have purposely made this device short and observe the effect of this upon the parameters. So inductor current is continuously rising, output voltage is continuously decreasing. So if this inductor current is not limited or not controlled, then that may damage the device. Similarly, I have checked with this inverter, basic inverter circuit. So I have made the short circuit fault with this T1, and I observed the effect of this. So inductor current is continuously rising. However, the output voltage is only positive, so there is no negative voltage. So performance also degraded, and also there are some care must be taken with this very high increase in the current. So these are the some circuit diagrams or the researchers' work already done by the different researchers. It is just for understanding what are the different types of diagnosis variable is used for the fault detection. So in this case, wind system, power electronic control system. So there are different converters are there. Inverter is there, boost converter is there, rectifier is there. So by measuring the output, input voltages and currents, this particular research is done, and comparing these two with the some threshold values, fault is get detected. In the second figure on the right hand side, you can see the in the interlude DC-DC boost converter, again some input output voltage parameters are get compared with the threshold value. So there are different types of diagnosis with these converters, and here the model based diagnosis is shown in the last figure. So we'll talk about this in the next slide. So this is the summary of this literature survey. So in the DC-DC converter, for example, I have analyzed this, what type of semiconductor, what type of the faults are there, whether these faults are with the semiconductor device or the passive elements like capacitor, inductor, what type of faults are there, OCF or ACF, and this which is the diagnosis variable that is used for the fault detection. So in this case, the slope of the inductor current is used, and what is the switching frequency for that particular switch. So in this case, detection time is around TSW, that is the switching period of this switching frequency. So accordingly, I have prepared this table, and what are the different fault diagnosis variable is used. So some of them have used the slope of the inductor current, some of them have used the output voltage, input current, then some fault signatures using this model based method. So accordingly, I have identified this, and this is the final inference from this literature survey. So according to this, either an inductor current, the switch voltage, or the converter input voltage, output voltage, also it is along with the switching control signals, or combination of these can be used for the diagnosis purpose. So as also I have observed that more the parameters, more will be the sensors required for their measurements, and this may lead to the increase the complexity of the systems and thereby increasing the fault detection time. So here that's why the effective fault diagnosis technique is in which there should be simplicity with the low cost and fast fault detection. That is the main concern in the development and design of this fault diagnosis techniques. So this is the stress-based modeling and observer-based fault detection in bug DC-DC. So in the first part, I would like to discuss about this stress-based modeling. So what are the importance of this stress-based modeling? One is the dynamic analysis. So it provides the insights into the static and
Sorry to interrupt you, sir, but due to time constraint, we do not have time. So I would like to request you to kindly wind up within 2 minutes.
Okay, sir. So these are the advantages. State-based model has been designed, and according to this state-based model, the further observer is also decided. I have also analyzed the different, the dynamics of these open loop and closed loop dynamic systems. So this is the closed loop, open loop systems. So we can see the dynamics where the two state variables are shown here. So according to our requirement in the dynamic response, so there should be a required overshoot, rise time, all these things. So for that we can use the feedback. So if you use the feedback, then there is again a problem with the DC gain adjustment. So using the DC gain compilation, we can remove that particular problem. And finally, we can have this type of observed design. So with the observed design, we can see the dynamics. So this is the very good dynamics. So how this particular observer now can be used to detect the fault. So if the system dynamics are reprinted by this general equation, state space equation, then observer can mimic or that can estimate this particular state variables based on the input and output given to it. So the second equation is the observer mimics or the estimation where the state variables can be obtained based on the outputs and the inputs. And finally, the residual is the difference between the output of the system and the output of the observer, which gives the residual, and how that residual can be used to detect the fault. Also, I have analyzed this one. What is the effect of this capacitor ESR upon the dynamics? So due to the ESR, so first waveform is the without RC, that is the capacitor resistance, series resistance, and this is with the presence of RC. So this RC introduces the that disturbs the dynamics. So it introduces the more ripple in the output voltage, and this is the effect. Then I have formulated this observer with this, and again here. So this is the left hand side is the pre-fault state space model of the buck converter. Right hand side is the state space model with the buck converter. So if there is any change in the inductor or change in the capacitor, then how this model will be get converted into this form. So that is given here. So with the presence of this fault, as we know that the observer will create some output and the residual will be generated. So for that, I have obtained these signatures for the capacitive and inductive faults, and according to I have prepared this, and these are the some results. So in the first case, we can see that if there is no any fault in any components, then we can have the zero residual in the third graph. So these are the first two graphs are the one is the output of the that system which is under control, and this is the output of the observer. So residual is zero because there is no fault. So once the residual is or once the fault is generated, so I have made the fault in the inductor just by increasing its value by 10%. Then this will generate the residual, and this particular residual can be used to detect the fault. This is about the capacitor fault. So if the value of the capacitor is changed by 10 microfarad or changed to by the 10 microfarad, then how this particular residual is generated and how this residual can be used to detect the fault. This is for the inductor fault detection and open circuit fault detection results. These results are in for the different duty cycles. And then finally, I have implemented this. I am still working on this hardware part implementation. I have used the disk-based controller for implementing this particular model. And I obtained for the duty cycle 60%. Enlarged view can be shown here. So we can see here, I have used the fault tolerant control also. So after detecting the fault, I have used one redundant switch in parallel with the main switch, so that when the fault is get detected, immediately after that redundant switch comes into the picture and the operation is continued. So we can see here the output voltage is continuous except this particular small decrease in the voltage. So on this hardware implementation, I am still working on this. So finally, conclusion, a model-based approach for fault detection and identification for the buck DC-DC converter has been developed. And I have also validated this with the help of the Simulink, MATLAB Simulink, and also I am working on the hardware part. So this is from my side. So your valuable suggestions, sir.
Hello.
Yes.
Satyavan sir.
Yes, sir.
Sir, you are actually senior to me. So I cannot suggest, means I cannot question you. Anyways, I have only suggestion for you.
Yes, sir.
Sir, like many of the graphs I saw, the y-axis were not marked.
Yes, sir.
So this is only the suggestion from my side.
Okay, sir. Thank you. I will.
Okay, sir. Thank you, sir.
Thank you, sir.
Rachit, next presentation.
Yes, sir. Now I would like to invite the presenter from paper ID 489. Thank you.
Hello, can you hear me?
Yes, you are audible.
Yeah, I present today.
Okay, thank you very much. Now you may proceed with your presentation.
Yeah, thank you. Just give me a minute. Is it visible? Hello, can you please check if it's visible? Okay, I shall continue now. So good afternoon, everyone present here today. My name is Ananta from Amrita Vishwa Vidyapeetham. Thank you to SPIN for giving me this opportunity to present our work on such a distinguished platform. I will be presenting our work on comparative analysis of finite automata and pushed-down automata for an elevator system. So elevators are a crucial part of urban infrastructure, but traditional models lack efficiency in handling dynamic requests. Our study explores how finite automata and PDA perform in managing elevator controls and the real-world applications. So this is the agenda of today's presentation. I'll first be introducing about our project and then move on to what motivated us to solve this problem, the challenges that we faced, the research gaps, and then we'll move on to the methodology performed, a comparative analysis of what actually did we observe in finite automata and PDA. And then we'll come to the results, challenges, drawbacks, and then the future scope. First of all, why is this study important? Elevators must handle real-time requests, prioritize them, and operate efficiently. Traditional finite automata-based control systems work sequentially, making them inefficient for modern high-rise buildings. So our objective is to compare finite automata to determine which is more suitable for real-world elevator system. So what is the key goal? It is to analyze finite automata and PDA for elevator control to evaluate their efficiency in handling requests, energy management, and prioritization. To determine which model is better suited for smart elevators, we had to do the study. Now coming to what is the motivation for this research. So growing demand for smart elevator systems with in place of FA-based models struggle with real-time prioritization. Inefficiencies lead to longer wait times and energy wastages, making it a time waste for people. So what is the challenge? The main challenge was that in finite automata, there is no memory and cannot store past requests. And it only processes the limits from users sequentially and no dynamic prioritization of requests. So what did we do to contribute for this challenge? A comparative study of finite automata and PDA for elevator control system. Implementing PDA with priority queues to improve response time. We implemented priority queues in PDA to improve the quality and the energy efficiencies for these elevator systems. So where does this study fit in? So most of the studies always showed about FA being widely used in pattern recognition and FSM based systems. FSM here means finite state machines and compilers. So PDA here used in parsing, language processing, and hierarchical structure. What was the gap in this literature survey that we addressed? So there is no comparative study on finite automata and PDA, and there was lack of research on handling simultaneous and dynamic requests in elevation. So this performance trade-offs between finite automata and PDA were not explored in any of the studies which we addressed over here. So this is the methodology for our finite automata state diagram for elevator system. The finite automata work for elevator control has the following states like idle, opening door, closing door, moving down, moving up, emergency stop, and more. So we use these states to compare which way it is going, the elevator system. And the limitations of finite automata was that it cannot store previous requests, processes one request at a time, but it can't process multiple requests from different users. And this transition between states are deterministic. For example, the elevator is moving up and down based on the request, but not optimize multiple requests, not based on optimizing the multiple requests, because there are not minimum number of people always. There are many people, and we will have to be able to optimize multiple requests dynamically. And finite automata fails to do that. Coming to PDA's implementation, let me first tell what the notations here mean. C is the current state, R means request, Z means the start state in our PDA, the empty stack, and I is the idle state. Now, here we've used the same states too: idle, floors, moving up, down, opening door, closing door, and emergency stop. So PDA uses a stack to store and process flow requests, which is not something that is there in FA, finite automata. Works with push and pop operations. The push operation adds a new flow request into the stack, whereas the pop serves requests based on the priority. And this priority is done using the priority queues concept. Now, PDA allows reordering and prioritization requests dynamically. For example, there are already 3 requests, for example, 2, 5, and 7, and another new request want to be added, and we want to add another new request. It dynamically sorts them in using the priority queue concept. And so the key advantage is that it handles multiple requests simultaneously without missing priority order. Now, this is the main observation from the comparative analysis we performed on finite automata and PDA. The key takeaway was that PDA outperforms finite automata in handling complex, high-traffic elevator operations. I'll go in detail with this comparison. First, the memory, as I told earlier, finite automata is stateless, whereas PDA has a stack-based memory. It stores requests. And finite automata handles requests sequentially, but PDA can process multiple requests at once. And nested requests, what I mean here by nested requests is that it refers to flow requests that occur while the elevator is already processing an existing request, requiring the system to adjust priorities dynamically. So finite automata does not have this nested request property, but PDA makes it accessible for that. And efficiency, finite automata is good for small situations. For example, if you are using it for a house building, but in PDA is better for situations where you are going to malls and hospitals like that. So next. So what did our implementation show? Finite automata is efficient for basic elevators but lacks memory and prioritization. But PDA improves request handling but adds computational complexity. Our Python implementation using Kindred GUI shows clearly the differences between how FA handles requests sequentially and PDA handles requests by optimizing the priorities. So the conclusion is that the trade-off between finite automata and PDA is that finite automata is simple, simplicity. PDA is functionality. The drawbacks that we encountered while doing both these FSMs were that FA cannot store past requests, no dynamic priority handling, and it fails to work in high traffic scenarios. Whereas PDA, it has a stack overflow risk, which is really very important, which is not possible in high traffic, whereas it also consumes higher energy because of the stack, and it is more complex to implement. So what I think is a solution for stack overflow risk is by using different FSMs like Turing machine, which has infinite power, memory, infinite amount of memory, and also can be done using AI-based optimization, which can further enhance the performance. And I'd like to, what did we learn from this study is that FA is good for simple elevators. PDA is better for complex high-rise buildings due to stacked memory, and a hybrid finite automata plus PDA approach could be the best solution. So in future scope, we could add AI and machine learning for real-time request optimization and also advanced techniques to not stop the elevator when the capacity is almost full inside the elevator. And using hybrid computational models like FA and PDA together. And I'd like to give my final thought that a smart elevator system is not about moving between floors. It's about optimizing movement for efficiency, energy conservation, and user convenience. And these were a few references, one of the few notable references that we have used for our study. And that's it for my presentation. Thank you so much for this opportunity.
Hello, Ananta.
Yes, sir.
You stated like, come to your table where you have made the comparison.
Just a minute. Can you give me a minute? This one, sir.
What is this FA and what is this PDA?
FA is finite automata. PDA is I'm sorry, push down automata.
Be alert on this. You are working on this and you are not getting it. Okay. Okay. Anyways, means you have just done a comparative analysis on these two.
Yes, sir.
So this is already available. So what's new in this?
That's what I addressed in our research gaps. There was no comparison between finite automata and PDA in our previous research, and they haven't explained how they have handled simulations and dynamic requests using PDA. It was not stated anywhere, so that's
you
why
could have means no citation is also shown, like from where you have taken this research gap or from where you have got this. So these are suggestions which you can include. Okay.
Yes. Yes.
Okay. Thank you.
Yeah.
A nice
Thank you,
presentation. Thank you.
Thank you.
Thank you very much. Now I would like to call upon the presenter from paper ID 579 to present their paper.
Paper ID 579, Gayatri. Hello.
All right. Yes. It's done. Now you may proceed with the presentation.
Yes, sir. Good afternoon, everyone. I am Mutyam Gayatri Priya. I am honored to be here today at 12th International Conference on Signal Processing and Integrated Networks to present our research on developing a low-cost electronic control unit for a hybrid electric vehicles using CAN bus protocol. This work has been carried out with my co-authors at Amrita School of Engineering, Coimbatore. Our focus is on designing an affordable, scalable ECU system for hybrid electric vehicles, ensuring efficient communication and energy management through the CAN bus network. As automotive technology advances, vehicles are becoming increasingly reliant on electronic control units. ECUs play a crucial role in managing vehicle functions, improving performance, safety, and user experience. The growing shift towards the electric and hybrid vehicles makes ECU optimization even more essential. Hybrid electric vehicles require precise coordination between multiple ECUs to manage power flow efficiently. In our research, we developed and integrated ECUs into a CAN-bus-based network, improving communication between different vehicle subsystems while maintaining low cost and highly reliability. Prior research highlights various ECU, like here comes the literature review. Here, prior research highlights various ECU applications in hybrid vehicles with a focus on motor control, energy management, and driver assistance systems. However, most studies focus on individual ECUs functionalities rather than their interconnection within a CAN bus network. This limitation has led to a lack of seamless communication between ECUs in many vehicle systems. Despite advancements in ECU development, few studies explore the interconnection of multiple ECUs within a CAN bus network at a cost-effective scale. The available solutions are either high cost or complex, making them unsuitable for budget-friendly hybrid electric vehicles. Our project bridges this gap by designing a small-scale standalone of a microcontroller-based ECUs with optimized intercommunication with the CAN bus protocol. Next comes the objective. Our primary objective of our study are developing a standalone ECUs for key functions in hybrid electric vehicle, facilitating the communication and data sharing between the ECUs using the CAN bus network. We are implementing the 3 ECUs, which are hybrid vehicle motor control ECU, advanced driver assistant system, which is ADAS ECU, and infotainment ECU, where we will be displaying the dashboard alone. Next comes our block diagram for the hybrid vehicle control ECU. Here we have manages the in hybrid vehicle control ECU. We manage the motor speed and the power distribution. Uses a 12-volt battery and a DC to DC boost converter to step up the voltage to 48 volt. It ensures the efficient energy management and communicates the key parameter like motor speed and the SOC data to other ECUs. Then comes next ADAS ECU. In ADAS ECU, it enhances the safety by processing the sensor data from the ultrasonic or radar sensors to detect the obstacles and communicate the information to the hybrid vehicle control ECU and adjust the motor speed accordingly, and even to the infotainment issue, which is the dashboard ECU. Then comes the infotainment ECU. In infotainment ECU, will be displaying the vehicle data and the safety alerts, ensuring the user experience. Then comes these 3 ECUs, how we are communicating with the CAN bus network of the synchronized operation with message prioritizing and the error management, ensuring the real-time responsiveness. And then this is how our methodology of the 3 ECUs have been developed, and how ECUs interact through CAN bus for how fast the exchanging of the message has been simulated according to the message prioritization. Then comes here is our hardware implementation of the ECUs, where we have developed it for the dashboard purpose to display to display the data of the vehicle and giving the traffic alert. Then comes our results. In our results, first thing is our speed of a DC motor. Our simulation of a demonstrate how motor speed varies with the state of charge. As SOC drops to the 40%, the ECU signal automatically decelerates until the battery is recharged. The infotainment ECU simultaneously will activate the low battery warning on the dashboard. This integration prevents the sudden power loss and ensures the vehicle safety. Then comes the battery SOC and the relay operation waveform. Here, the battery SOC graph shows that as the motor runs, the SOC decreases gradually. When SOC reaches the 40%, the ECU sends a signal to cut off the supply. Then here, it stops the motor and it prevents the deep discharge. And then comes the results of our DC to DC converter PWM signal. Here, the pulse width modulation signal generated from the ECU for the DC to DC converter was observed in a 250 to 268 second time frame. At 264 seconds, the PWM pulses stop cutting the power to the motor. Then we have used the 50 kilohertz frequency as lower off time results in a more efficient DC-DC conversion process, which optimizes the power transfer. Next comes the GUI dashboard for the traffic alert. Here, this verifies the ADAS ECU functionality. When an obstacle is detected at less than 25 centimeter, the ADAS ECU instructs the hybrid electronic control ECU to halt the motor and alerts the driver. The infotainment ECU also displays the traffic indicators, ensuring the timely driver responses. Next comes the waveform of vehicle speed analysis. Here, speed waveform analysis, the analysis categorizes the vehicle movements into 4 zones, which is acceleration zone. In acceleration zone, speed increases as power is supplied. Then deceleration zone, speed gradually decreases. Then traffic alert cutoff zone. Here, ECU slows down the vehicle in response to the detected obstacles. Then completely stop. The vehicle halts when the speed reaches the zero. These phases confirms that our ECUs can efficiently regulate vehicle movements and safety. Then comes our perspective of the comparison of the present ECUs was the proposed low-cost ECU cost comparison. Low-cost ECUs are affordable, energy-efficient solution for budget vehicles and emerging markets, focusing on essential functions like diagnostic and basic ADAS. Here, when comparing our low-cost ECU design using microcontrollers like STM32, ensures essential functions such as motor control, while premium microcontrollers like Infineon and Renesas provide high-speed processing. Our solutions offers an affordable alternative without compromising the core functionalities. Our low-cost ECUs is affordable, scalable, and energy efficient, consuming less than 5-watt power consumption. It focuses on the core functions like diagnostic and basic ADAS, making smart vehicle technology accessible for budget vehicles. Despite its simplicity, it supports key safety features like collision warning, enhancing road safety without high cost. Then in conclusion, our study successfully developed and simulated a low-cost ECU framework for hybrid electric vehicles. By integrating these ECUs into a CAN-bus network, we achieved seamless communication between the ECUs, enhanced energy management, improved vehicle safety and efficiency. While our approach provides a viable low-cost solution, challenges such as latency, power consumption, and real-time optimization require further refinement. Then here, going forward too, we plan to for our future scope as enhance the ADAS functionality such as adaptive cruise control and automated the energy emergency braking, and optimize ECU hardware to reduce the latency and power consumption, improve the scalability for high-end vehicles while manufacturing the affordability, and transition from the simulation to physical hardware prototypes, making our solution more practical for the real-world application. These advancements will contribute to next-generation hybrid and autonomous vehicle technology. Here comes our references. Our work builds upon this prior research in ECU design, CAN-bus communication, and hybrid vehicle optimization. We acknowledge the contribution of various authors whose studies have influenced in our project. That concludes my presentation. Thank you for your time and attention. I'm happy to take any questions.
Thank you very much. If anyone in the audience has any questions, you may unmute yourself and ask.
Hello?
Hello, sir.
Yeah.
Yes, sir.
Mutyan. Come to your title page, please.
Okay, sir. Title page. Yes, sir.
Just a sec. This is development of low-cost electronic controller. So the controller which you are showing,
yes, sir,
is developed by you, means your team.
Yes, sir.
Have you worked on that?
Yes, sir.
What is the efficiency of its performance? Like you have worked on it, you have designed it. you are means practically implementing that part. So is there any irregularity like which you will be means what to say like in future this is mistake we should improvise this type of any.
It's up to like around 1 second is the latency which we have developed, sir. The speed of the controller is up while simulating how fast it has been worked is up to a 1 second. And also our CAN bus data is just an 8 bytes of data, but in real world it is around 64 bytes, sir.
So 8 bytes and 64, there's a much difference now. So
Yes, sir. As we add more peripherals, then our byte would be like it would be increased to the 64 bytes. As we are using only the speed and SOC data, we are sending it as 8 byte. For speed, both together, we are sending it as an 8 byte because we are using only the two data for the from the motor control. It's just like a, as an example, like just like a prototype.
Okay. Yes. Thank you. All the
Thank
best.
you. Thank you, sir.
So that was the final paper presenter. I would like to thank each paper presenter who presented their paper on their hard work. It was a really fruitful experience. I would now request Dr. Anil Kumar Shukla to present Dr. Amit Kumar Chaudhary a certificate as a token of appreciation for being our session chair. Thank you so much, sir. Your presence really lifted our experience.
Thank you so much, Professor Amit, for sharing your valuable time with us. It was a nice presentation for all presenters. Thank you so much. Thank you so much once again.
Thank you, sir. Thank you, Team SPIN 2025, for allowing me to session a chair. Thank you.
Thank you very much, sir. Paper presenters, your certificates will be sent to you via the email shortly. Thank you for valuable contributions. I would now like Dr. Amit Kumar Chaudhary's permission to close the session. It's been a privilege to have you all today. Make this session a success.
Okay. Thank you.
Thank you once again, sir, to take some time out of your valuable schedule and be a part of SPIN 2025.
Yeah, sure. Thank you.
Thank you for being a part of SPIN 2025, everyone. You have been a great audience. Thank you. IT department. IT department, please close the meeting. Thank you.